Good morning, everybody. We are starting the second day of the GRWSC 24. We will be having 4 technical lectures here in this session. One by Professor D.N. Singh, next one by Ananta B. Rao, third one by the Venkat Siva Naga, Sai Goli, Brunal, and D.N. Singh, and fourth one by the N.C. Kotial. And then we'll be having the discussion session. First, I would like to invite Professor D.N. Singh. He is professor at IIT Bombay, working there for more than 30 years, and is the DLSA professor for innovation at the IIT Bombay. He is the man of research who have guided around 40 PhD or more than that, and he is the reviewer of many journals, and he did lot of projects, research projects at IIT Bombay. I invite first Professor D.N. Singh for his lecture. You have 30 minutes for the presentation, so request to finish within the time. Thank you.
So good morning, everybody, and thank you very much, organizers, for such a lovely meeting over here at Warsaw. Many people are saying that they are here because of the title of the talk. The one word which I have written in black might be a magnet. So I'm going to talk about or share my experiences about what are the challenges which are lying ahead. You know, we always boast that we have done a lot, but truly speaking, it's not so. And in the due course of time, I'm sure you are going to realize that we have to restart our journey because we know a little about what's being done and what is being discussed. So just for a quick reference, thankfully to my friend Magdalena, I was asking her what is the equivalent of English word ecstasy in different language. Well, of course, I can't speak them. So the whole idea is a sort of a euphoria, like when you know that you don't know much, but you know that you have to do a lot. That is the whole idea. So I am the founding editor-in-chief of Environmental Geotechnics. I will take you through that journey also, what prompted me to launch this journal and where we are exactly. And needless to say that we are still thinking what we should be doing further. So the title of this conference is very much in line with the ancient Indian medical scriptures, which are known as Ashtang Hridaya. Hridaya means heart. Ashtang is 8. So whenever you get time, please go through this. It is believed that the modern medicine system has come out of this. And what it says is, which is very contemporary to the theme of the conference, EGRWMSE, Jagat me Manaushadham. That means in this world, there is nothing which is not a medicine. Provided you have synthesized it, provided you have done research, and provided you have done enough marketing of it. This was written maybe 2000 years back. So no natural material resource can be a waste. And this is what we say that this should be a man-made material. It is we who do not know how to utilize it, how to value it, how to create money out of it. And hence detailed research is required. So Professor Krishna Reddy, congratulations to you, because I'm sure you must have got motivated by this shloka. And you must have kept the name EGRWMSE. I have been asked to talk about the Indian perspective, where we stand. I hope most of you are aware of that if you compare the 25 economies of the world, we are standing at 5th position right now. These are recent information. This is where the India is. This is as per GATP. And annual growth wise, we are also fifth with 6.8% enhancement in the growth of the country. Whenever growth occurs, definitely we are going to have many challenges. So I am going to talk about a bit on these challenges subsequently. What Government of India is doing in this context, just wanted to give a brief idea about this. There are a lot of initiatives, and the best initiative is if you have traveled recently to India, when the landing occurs in the aircraft, they announce life. What is life? So this is the lifestyle for environment. This is the central agenda of Government of India right now. And what is being done is to encourage individuals to adopt lifestyle for environment. I think this is the best part of the education which we are planning to give to our juniors, students, family members, and so on. So if you look at the life themes, save energy, save water, say no to single-use plastic, adopt sustainable food systems, what Magdalena was talking about yesterday, reduce waste, adopt healthy lifestyle, and reduce e-waste. So these are the 7 themes on which the main focus is. And to promote the responsible consumption and production of the resources, reduce greenhouse and gas emissions, support the United Nations in SDGs. So this is the main agenda. And what I realize is that environmental geomechanics very easily gets connected, overlapped with these themes. Now, if you talk about the agencies and the policies which are getting implemented in India right now, the CPCB, that is Central Pollution and Control Board, is the main custodian of environment. A lot of initiatives are there. Yesterday, some debate was going on that what should be the role of the government as far as the waste management is concerned. I don't see that gentleman over here, but the answer to his question is a lot of policies have been created since 2016. Solid waste management rules, Swachh Bharat mission. Bharat is India, Swachh is clean. E-waste management rules, plastic waste management rules, construction and demolition waste management rules, batteries management and handling rules, hazardous waste management rules, and steel scrap recycling policies. Now, what is the role of the researchers and the academicians? Most of us are guiding the policy makers of the country. And this is where again I see that there is a lot of scope for academicians and researchers like us to get into this practice of making rules, policies. Of course, enforcement is in the domain of the government. Smart city initiative which has been taken by the government, where all these rules have to be implemented. Then there is something known as Niti Aayog. Niti Aayog is planning commission. Niti is the planning. Ayog is the one which is the body which is implementing all the initiatives which are taken by the government. So this is where the main focus is strategy for resource efficiency and circular economy and blue economy. I hope many of you are realizing that this is the major shift which has occurred in last 5 to 7 years as far as the waste management is concerned. And this gives a lot of scope for people like us to work in these areas and exploit them. Just give you an idea about how linear economy to circular economy transformation is taking place in the country. We have 11 themes. Municipal solid waste, scrap metal, lithium ion battery, people were discussing yesterday, tire and rubber recycling, gypsum waste, end of the life vehicles, electronic waste, toxic and hazardous waste, used oil waste, agriculture waste, and solar panels. These are the initiatives which are given by the Niti Aayog, and then there is another watchdog which is known as MOEFCC, Ministry of Environment, Forest and Climate Change. So there is a dedicated ministry on this. Now coming back to my research areas and my students' research areas, we are very actively pursuing 5 of these 11 linear to circular economy things. MSW, waste rubber tires, gypsum waste, and toxic and hazardous waste. most of the policies which have been adopted by Government of India were created by my students, myself, and like-minded people from all over the country. So this is the initiative which academicians can take. So I call this group as ENVGOs. Some of the ENVGOs are here, Dr. Rao, Dr. Goli, my another MTech student, and of course you also, because Magdalena, you are a part of this ENVGO. There's another very interesting mission, and the gentleman who was discussing about, I'm trying to locate him, he's not here. There's a waste to wealth mission. So please go and click on this interface. All the latest technologies which you might be having and you would like to market them, this is the place. So circular economy also creates a marketplace. Now this initiative of Government of India, which is through the Prime Minister's office, we call it as a PSA, Principal Scientific Advisor to Government of India, which is championing waste to wealth mission. Any new technology which you have, you can register it. Doors are open to anybody all over the world. You can come and demonstrate it in the Indian context. There's another initiative which is taken by CII. And Bernard, if you remember, I was talking about there's a big delegation which is going from India to Japan. So CII is the Confederation of Indian Industry. They are very active in creating, again, the white papers on different type of technologies which are required to champion waste to wealth mission. A lot of initiatives are being taken. Then something like waste to worth, on which we are also working. I was lucky enough to lead a nationwide initiative through the Indian National Academy of Engineering, which is known as technology roadmaps with actionable recommendations. So we were trying to develop these guidelines, roadmap for industrial byproducts, IBPs, for sustainable infrastructure development. If you visit my website, you can get the videos and the details about this. So I'm skipping all that. There was another initiative which we took through ISEG, International Society of Environmental Geotechnology, where we created a virtual center known as SEGERIN, that is the Center for Geoenvironmental Research and Innovation. So you are most welcome to participate in this and then contribute to the knowledge. So having set this tone of what's happening in India, what is the perspective as far as the waste management is concerned, now let me come back a bit onto the philosophical side of what environmental geomechanics is all about. So basically we are trying to maintain and improve and safeguard the natural environment. In this picture, what you see is the very serene climate, environment, beautifully flowing white color water, everything is so good. Over the years, what has happened? We have destroyed it. So the main task which environmental geotechnologists are supposed to do is, we are going to be the architects of the quality of life. And when we say quality of life, what we have to do? We have to think about the future and future generations, and we have to fight against the Anthropocene epoch. Professor Koda has given this title, and he is championing one theme issue also. I'll be talking about this. Anthropocene epoch is something very big. It's beyond our lifetime. It could be hundreds of years, it could be 200 of years, it could be few thousands of years. So this is something which is attracting the interest of everybody in our domain. What are the challenges, way forward, the ecstasy for sustainable development? Now this is what has been created over the years, the mess. And most of these situations are forcing all of us to think about social issues. Environmental geomechanics cannot be done sitting inside the laboratory, because if somebody is establishing an industry or a manufacturing unit, the society is getting impacted, both in plus and minus. So we have to talk about the social issues, legal issues. Most of these issues become legal. Geopolitical. You are seeing what's going on in the name of the COPs every year. We are having, conference of politicians. They are COPs. They are discussing what to do, how to talk about the intercontinental pollutions, and so on. Sorry. Financial and technical aspects. So everything is becoming, combined together. Thank you. No. Scope is unlimited and ever increasing. And this is where the SDGs get linked to the whole discussion. Some time back, I wrote this book, Environmental Geotechnology, which is a record of my research and professional journey. And I hope some of you must have gone through it. This talks about the intelligent solutions which the society is trying to find out to come out of all this mess. And this is how the environmental geomechanics started. We wanted some excellent solutions, need-based. We can't afford big instruments, whatever the problems are. If I can give you a solution in simple way by not using major equipments, major resources, and the society is happy. These are the virtual hands which are keeping the baby happy. Baby is sleeping. This is what actually we should be doing. So I also talked about these discussions in one of my IGC 2018, which is the Indian Geotechnical Society conference in 2018. And of course, I offer a course also on this, environmental geomechanics. So let me now talk about the ecstasy, where we are heading, what should be done. And this list is ever expanding. A lot of things are to be done in the field of material science. Most of you are working on materials, C&D, nanotubes, concrete, composites. A lot of research is to be done in neo materials. Emerging contaminants, my friend Milind, and of course Krishna Reddy, they are all champions in PFAS, and of course Arvind, is it not? You are talking about different types of materials, how the leaching occurs, emerging contaminants, man-made soils and aggregates, which we are trying to do, mining, geoenvironmental aspects associated with the mining, geohazard mitigation. Geohazard has become a very difficult term to understand because this list is also expanding. I do not know which hazard to be included and which one to be excluded from this list. Earthquakes, landslides, volcanic eruptions, soil erosion, and so on. Pandemics, destruction management. Most of the world is severely affected by what's happening in the neighboring countries here. All right. What happened few years back? Pandemics. We survived. What happened to the economy? What happened to the geopolitics? And so on. These questions are unlimited. How are you going to manage these type of situations? Of course, the role of internet, IoT, AI, ML, expert systems. Yesterday we were discussing, Yelis, you were talking about, these types of issues. Yes. So definitely this has to be the central theme. Bio-geo-interface, molecular mechanics, fire, blast protection systems. Recently, Arvind, you have published this paper on wildfire, forest fire, volcanic eruptions. This is becoming a major theme in our subject. Infrastructure engineering, land creation. Most of the nations want to expand geographically. From where you are going to bring the soil, from where you are going to bring the resources. That itself is going to be a part of the environmental geomechanics. See, this is the ecstasy. This is the joy. This is a challenge. We understand these are very difficult terms to answer, to address, but yes, it's a sort of a intoxication which you have done to your body that you remain busy without thinking about rest of the world and you are busy with your work. So that's what I said. List is never ending. Preservation, restoration and rehabilitation of monuments and the old structures. Arctic, cold region. Those of you who are working in the field of gas hydrates, CCUS, clean energy, I am sure you must be talking about this. As a country, we are also now in the lunar and Martian race. We were talking about the lunar mission, Martian mission, space, extraterrestrial space. No wonder, after a few years, we might be having colonies over there. Again, geotechnical engineers will be required. Forensic engineering is an old subject. People have been practicing it. Engineering aspects associated with the legal problems. Energy transition. This is going to be a big thought for all of us. How we are going to deal with the net zero, which our politicians commit in every forum. It's very easy to commit, but how are you going to achieve it? How are you going to address this? How are we going to train our students and the future generation? Our research group is quite active in energy transition, gas hydrates, geothermal, energy from oil and gas wells, CCUS, carbon capture, utilization and storage, carbon capture, utilization, and enhanced oil recovery. So these are the topics where you have different types of, soil, gas, environment, water interaction. Climate change. I was telling even, I would like to understand what climate change is all about. Everybody is using this word without understanding how to quantify this, how to understand the impact, how to correlate the two. These are becoming very, very big words. Glaciers are melting, droughts, floods, cloudbursts. Can this term answer all these issues? There is a role to be played by environmental geotechnologies. So I hope you realize that the last point, which is the need of the hour and for human sustenance, is food, energy, and water nexus, which I think we can address very well. Visit Magdalena's lab. She does a lot of experiments on how to grow, vegetation on different types of soils. Now, when soils are also man-made, what type of vegetation we are going to create is another question. So maybe subsequently we are going to talk about, you are going to hear from Dr. Goli and my other research group how to create man-made soils. And of course, geospatial engineering and geoinformatics, which is going to play a very, very important role in our subject. Continental drift, plate tectonics, natural resources, their depletion, their identification. Keep on adding to this and sharing it with me. This itself is a big excitement and joy for realizing that we don't know much in our own subject. So we launched this journal about 12, 13, 14 years back, Environmental Geotechnics. At that time, my idea was that I would encourage authors to write new perspectives. And in the meantime, what has happened? The perspectives themselves got changed. This itself is a joy, mystery, correct? How to handle it. So we conceived this with the help of many of my colleagues here who are the editorial board members. Brendan is there, of course, you are there, Magdalena, Koda is there, and so many. And Krishna Reddy was also a part of this earlier. And of course, I can't find some more faces. Anyway, so we started very modestly with 4 issues per year. And then at that time, the basic concentration of the theme was geometrical contaminant interaction. But then we expanded. SDGs came later in 2015. All right. And then what happened? We have now grown to 9 volumes per year. That itself is a joy, uncertainty. We have encouraged a lot of multi-authored papers, multinational collaboration. This is the beauty of, environmental geotechniques. Different authors from different continents sharing their thoughts, knowledge, addressing several SDGs. I think, Andrea, you started this concept during the COVID time. You gave me a challenge, is it not? Do something sitting at home and bring all these authors together. So we championed this concept. This is what the outcome of the COVID-19 type of a situation is. When the entire world was scared, we were working on the special theme volumes, and we were the first to come out with these papers. Geotechnical and geoenvironmental engineering education during pandemic, municipal solid waste management under COVID-19, challenges and recommendations, design of mass burial sites for safe and dignified disposal of pandemic fatalities. Post-COVID-19, water and wastewater management to protect public health and geoenvironment. Environmental geotechnics, challenges and opportunities in post-COVID-19 world. In nutshell, the theme of this presentation here is we have to move on. And how we are going to move on? We are going ahead with some dedicated call for papers. Gas transport in clay materials. Krishna Reddy, you have done a lot of work on this. Environmental geotechnology in changing climate challenges and opportunities, climate change. Please volunteer, write some good papers and teach us. Because absolutely, I have no idea that how these things can be correlated. Gaseous flow in low permeability geomaterials. Use of biopolymers in environmental geotechniques. And of course, what Professor Koda and his group is championing is waste generation and management in the Anthropocene epoch. Trends, challenges, and sustainable solutions. This list is also never ending, because I keep getting a lot of suggestions for future call for papers, but because of the restrictions from the publication side, we cannot expand so much. There are several, most read papers, most cited papers. If you look at this, microplastics, Brendan has championed this. Brendan is sitting here. Microplastics in soil and environmental geotechnics perspective, sustainable environmental geotechnics, green economy, assessment of remediation, strategies, and so on. I'll just conclude my talk by saying that environmental geomechanics is ever evolving. It's not going to get over soon. Extremely difficult to master it, at least in one's lifetime. So, I think always that how to expand the realms of the subject. So, very recently we wrote a book on cricketing pitches. Cricket is the national religion of the country like India, Pakistan. All right? Economy depends on this. How the environmental conditions would affect the mineralogy and how you can create good pitches. And of course, lunar environmentology, because now we are also in the race of reaching moon and Mars and whatnot. This is a good sign. We are constantly changing ourselves, facing new challenges, and that's the ecstasy. That's the joy of being in a profession which does not let you sleep ever. You're always on your toes. Thank you very much for a very patient hearing. I'll be very happy if you keep sending your suggestions to how to improve myself, of course, my research group, and of course, the big baby which we have delivered, environmental geotechnics. So this is a typical posture from India, which says namaskar. Namaskar means saying hello. And of course, this is a lotus flower, which is our national symbol, national flower, and it's a big philosophy. So thank you very much.
Thank you, Professor D.N. Singh, for finishing the lecture within the time limit. And it was an excellent keynote lecture. Thank you very much. You have shown the various new areas.
I think many people may be interested in having some discussion, so maybe last 10 minutes, I think we will decide.
Can we give the 2-3 minutes time now?
Yeah.
Because he has finished early.
Yeah.
Okay, we have 2-3 minutes for the question answer session just now with Professor D.N. Singh.
Anybody has any question?
Yes, please.
Ivan, it's okay. Yeah. We can discuss over lunch.
No, just a mic.
Just wanted to ask something which is a little bit broader, since your discussion was, your presentation was more philosophical. Is it more ecstasy or is it depression? Because in my talk, which I will follow up later, I will put a big question mark on the ecstasy.
You see, when we know what do you mean by your question of depression. When the general public is depressed, now that is where we have to come out with the self-esteem. That is the ecstasy. You should not be depressed. That's what the example of COVID is. During COVID time, 5 papers. We shook the entire world. How many countries? You are not sure about tomorrow. So one of the authors was writing to me, you are dictating as if you are going to live forever. And seriously, from China. I said, don't worry, even if I am not here, somebody will read my emails. So it's not depression, it's a challenge. Take it as a challenge. We are surrounded by all uncertainties. Excellent. But this is a challenge for the profession. I will hear your presentation also. Yes, please.
Yeah, can you hear me? Yeah, Professor Dennis, thank you very much,
My pleasure.
especially for the warm words about us. We appreciate our
Yes.
cooperation. It's really, I mean, I will come back.
Sure.
I have to make more pictures.
Okay.
And going back to the topic of the Anthropocene, well, it's a huge topic. I mean, it's very difficult for us to publish with the waste management and the landfills because the geologists are stopping us. But I think, as you were showing, the waste problem, it's a sign of the Anthropocene, and I think we should fight for.
Correct.
Yeah.
Yeah, that's what I'm telling you repeatedly. All those who are hearing over here this discussion or any other similar discussion, there is a lot of things to do. It's not that we have done and we have written a book and we have written papers. They are also becoming outdated. If you read yesterday's paper, you realize that, well, whatever the guy said has no context in today's scenario. It's not correct. And that's the joy. It's not depression.
Yeah, I think your talk is very fascinating, and you identified all these grand challenges, which is very nice. But the problem that we have right now is, the curriculum that we have, the education system that we have, we still have that siloed approach, right? I mean, like if you look at geotechnical engineering, many places we teach the traditional subjects, and all these things, they require beyond the geotechnics, many other fields. So either you have to work with other people who have that expertise, or at least you need to have some basic knowledge about other topics so that you can communicate well in a meeting. So that is the big challenge, because still, our education system is siloed.
Correct.
How do we broaden that one up?
Oh, you are already doing this. Your name is Krishna. You know what is the meaning of Krishna? Just check it on the internet. Krishna. It's not Krishna. It's Krishna. The one who eliminates all the sins. Got it? So he has been doing a very fascinating work. And no, I really appreciate it. Why? Because he's the guy who is trying to take all of us out of these silos of the curriculum. Look at the web series, the seminars which he does. What you are saying is getting reflected there itself. You are calling people from different walks of life, different professions, and that's what actually you are doing. You have already started doing this. So the ideas match.
But the problem right now is, somebody wants to do PhD, and then, the faculty is just interested in their own things that they have been doing, so they want students to pursue that one. So how do you, change the mindset of faculty, right? Who will be willing to learn, right?
Good question for today's dinner.
Yeah, I know. That's
And you are going to host it for me.
Yeah, that's anytime.
Actually,
the big challenge.
I tell you, we don't need masses. We just require 2, 3, 4, 5 guys. That's it. We don't need masses. Masses will create more chaos. Clear? We just need 5, 6 guys who can follow what we are saying. That's it. We'll discuss this later.
Okay, sir. We will discuss
Thanks a lot.
later. Thank you. Thank you for the excellent keynote lecture. Now, I would like to invite Dr. Anant B. Rao, who is Associate Professor at IIT Bhubaneswar. His topic of presentation is Conversion of Industrial Solid Waste into Green Construction Materials for Sustainable Utilization. Anant B. Rao.
So good morning to you all. Let me thank Professor Koda for giving this opportunity and his team. Myself, I'm a Hanumant Rao, faculty member at IIT Bhubaneswar. So as Professor D.N. Singh, so in fact this is a great challenge to me to present my research outcome in front of my supervisor. No, you should be here so that so that I can be put in a right path. So as Professor D.N. Singh talking about neo-materials, so fortunately this presentation covers one of such requirement. So let us try to understand how to create the neo-materials. In fact, it is not only the neo-materials that we are talking, we also need neo-binders or neo-additives or neo-stabilizers. So to address the current needs of waste materials. So let me thank all of my student fraternity. So this is outcome of there, and these are my research areas. Okay. So in the era of waste materials, many people are working on different variety of the waste materials. So these are a few waste materials that is produced across India by different industries. But among all these, I could able to work for the last 10 years only on two materials, that is fly ash and bauxite residue. That too, remain confining myself to understand their basic behavior or physico-chemical mechanical behavior. So this presentation basically covers two aspects. One is how to create new geomaterial from the fly ash. The second one is how to neutralize the highly alkaline bauxite residue, which is a byproduct by the aluminum industry, by the bioremediation process. So the first one I talk is the conversion of fly ash into artificial sand by the process called as a geopolymerization. So when we talk about the sand, I don't need to talk about its source, so and where it is necessity, or who is the end user, so on and so forth. But what I mean to say is, I want to concentrate only on the creation of the artificial sand within the particle size range from 4.75 millimeter to 0.075 millimeter. Now, why I need to really specify the particle size ranges? So when I present another slide, you can able to understand it. Now, today, so many people are working on creation of the artificial aggregates by different processes. So all the processes are listed out here. We can go for cold bonding aggregates, or these are the types of the aggregates. And there are basically two processes I could able to find. One is sintering process, the next one is geopolymerization. But of course, there is a combination of these two also. So, and these are the four fundamental methods by which we can develop the aggregates. One is by the mold casting, or crushing, or hand mixing, or pelletization. So these are the four fundamental methods which are currently being employed so to create the sand material. But out of these four, the first three practically not able to be feasible to be implemented in the field, so therefore we cannot able to attempt it. But we can say the technology can be modified. While the last one, that is a pelletization, it is really challenging and can be extended to the commercial scale. So in my entire presentation, I'm going to talk about how the pelletization is useful to convert the fly ash into sand material. Yeah, so now let me give a clear difference between the existing technology versus that I'm going to talk our research outcome. The first one is, when I say the aggregates, it's not a new word, everybody knows about it. So in fact, this technology is already commercialized. We are producing the sintered aggregates. But the first negative aspect of it is sintered at 1200 degrees centigrade. So, and highly energy consumptive. Second one, when we go for the sintering process or this kind of the process, we produce uniform size of the aggregates. Okay, but what we require is a gradation. That is the most important. So gradation versus uniform size, there is a fundamental difference. To produce uniform size aggregates is quite easy, but to produce gradation from a single process is a really daunting task. So that's what I'm going to talk about. So here, this is our idea. So to make it an alternative to the sand, so when I talk about the natural sand, again I'm talking about strictly 4.75 millimeter to 0.075 millimeter in a single process. So here we have adopted two technologies. One is called as a geopolymerization. wherein we add the alkali activator solutions to the waste material or the byproduct material, that is a fly ash. And the second one is use something called as a cold bonding technique. Here also, we require some kind of an elevated temperature, but however, that is less than 100 degrees centigrade. Now, just to compare, when we are doing the sintering process at 1200 degrees centigrade, or where we are curing the same at less than 100 degrees centigrade, how much is reduction in the energy consumption? But of course, this is a seed of my research. I just now started it. So we also have another technology where I could able to bypass the requirement of the elevated temperature by following the circular economy. So in this presentation, I'm going to talk about only the fly ash alone. But if you go to the circular economy model, you can completely eliminate the requirement of any elevated curing. So this is geopolymerization and pelletization. So these are the basic raw materials. We have used only the fly ash. Then it has been activated with alkaline solution, sodium hydroxide and sodium silicate. That's it. Then we put everything in the pelletizer. So let me show again. This is a small pelletizer with the radius of 1.2 meter and 300 mm depth. Now, what is the real challenge is the same pelletizer is equipment available even before we were synthesizing the sand to produce, as I told, the uniform size of the aggregates. So here, what we thought is we have modified the speed and we have modified the duration and we have modified the tilt angle. So by varying these three parameters, we could able to succeed. So this is what the novelty of the entire idea, and this has been patented. So these are this is the fly ash, the properties of the fly ash, the specific gravity, pH, the gradation, the morphological characteristics, then physical and mineralogical characteristics. So this is simple class F fly ash with aluminates and silicates. Then this is the entire process of making of the fly ash based sand that we named as the fab sand. So we have taken the raw material fly ash, alkaline activators, activate it, feed all the raw materials into the pelletizer. Now here, since we have done an initial attempt, so there is some kind of the semi-automatic, but this can be fully automized by feeding the raw material and by feeding the alkaline activator solutions also. Then take out all the materials and cure at less than 100 degrees centigrade. What we get ultimately is the sand. So as I told, when we talk about the gradation, I need to ensure that I am forming all the particles more or less uniform percentage, or like for example the coarse fraction or the medium fraction or the fine fraction. Unless otherwise my sand composes of all the three, I cannot say this is a sand. So therefore I have to make sure that I am creating all the three variety, that is coarse sand, medium sand and fine sand. So for that purpose we have separated the coarse fraction, medium fraction and the fine fraction. So this is the process, and these are the variety of the aggregates that we have created. So in fact, we tried with the two variety of the fly ashes. One fly ash is produced by the Vedanta industry and the second fly ash produced by the NTPC, that is our Government of India Thermal Power Plant Organization. But when we talk about the synthesis process, there are several parameters that can influence. So from the material side, from the solution side, from the process side, so on and so forth. So these are the list of a complete influential factors. Why these factors are required? Because as I told, so somebody's interest may be only coarse fraction, or somebody want to create only the fine fraction depending upon their application. So therefore, by changing all these influential factor, so I can arrive at more fraction of the fine or more fraction of the coarse. So this is a complete set of parameters that we varied, and this is also to produce the sand. So now this is outcome of our result. So on the left side you can see the fly ash which has fed, and the other side So these are the 27 number of trials, so that we got the artificial sand from the same fly ash. So you can literally see a shift in the gradation curve from the raw fly ash to the synthesized sand. So you also can also look at the x-axis, where we can literally see the coarse fraction, the medium fraction, and the fine fraction, which is completely distinct than the raw material, the fly ash. So then once we could able to succeed in synthesizing the sand, so then it was subjected to different characterization, because without characterization we cannot endorse any kind of applications. So therefore we have done extensive physical, chemical, mechanical, durability and leaching characteristics. We can say the technical acceptability, environmental acceptability and societal acceptability. So we try to address the technical acceptability in the form of a physical, mechanical and durability, and environmental acceptability in the form of a leaching characteristics. So this in fact I have talked about it. Yeah. So now let us try to understand, because I am showing only the photographs but not in terms of the parameters. So when we compare 1-in-1 with the river sand of the artificial sand, so with the different properties, because unless otherwise these properties are endorsed, nobody is going to recommend this kind of the waste material, or nobody is going to say that this is an alternative to the natural sand. So in terms of the specific gravity, or in terms of the density, or in terms of the shear strength parameters, or the permeability, everything matches very well. But there is some advantage also. If you look at carefully the density, so which I am getting is lesser. So this also slightly falls under the category of lightweight aggregate as per the ASTM classification system. So these are the morphological characteristics, just to understand, yes, the geopolymerization process is happening to create the sand, and the bonding is primarily because of the either say CHH mechanism or polymers, or whatever you call about it. Then these are the leaching characteristics of synthesized sand for potentially toxic elements, which composes around 12 to 15 numbers. So everything falls within the permissible limit. Then this is a simple to make you understand how much is the percent conversion of fly ash into the coarse fraction, the medium fraction and the fine fraction. So if you look at the coarse fraction, for all the trials almost it was less than 20%, but fine fraction was varying. But this kind of information is very crucial to understand our synthesis process. So then applications, yeah. So we try to superimpose where it exactly fits. So when I target the structural applications, for example, can I endorse this for the concrete or the plastering or the mortar? So therefore we try to superimpose on the gradation curves proposed by the ASTM code or the Indian codes. So like ASTM C33 or Indian code IS 383, or for the masonry mortar or plastering. So it matches, some of the gradation curves matches, some will not match. So we require some kind of the little bit moderation here, but holistically it matches. Then we also try to validate the results by again, so making the cubes. So here what we have done is, we try to cast two variety of the cubes. One is by using the natural sand 100%, the second is by 100% fly ash sand that we have synthesized. And here also we have gone for the geopolymerization technology. So these are all mortar cubes. So these are after subjected to the compressive strength, and these are the results comparison. The compressive strength, the cubes yield so as high as more than 50 megapascal strength after 28 days of curing. So with the natural sand, where the fly ash based sand yield more than 40 megapascal strength, which is significantly high. So it is very near to the structural requirement also. So then I can say that yes, it works comparable with the natural sand. So there are several aspects to it, because when I say we have synthesized the sand, the first factor that everybody is asking is what is its cost for a ton. So right now it's coming out to be around 4,000 to 6,000 rupees, but under different circumstances, because we used everything pure materials. But in reality, we never use such a kind of materials. Therefore, we need to work on, suppose if you go to industrial scale, how much is the cost reduction? So there are various factors. So here comes his challenge of your research also, because we used the pure alkali activator solutions. This is where I'm talking about. When we talk about neo-binders, so can we think of partial substitute to the sodium hydroxide? Because we need to understand the role of sodium hydroxide or the sodium silicate at molecular level. Then we can create another binders. Or this is required if you typically follow the circular economy. This works only for the linear economy model. So this is the patent. So it is accessible, published, open, but not granted it. Then we are also going for the pilot scale project of the same thing with one of the government agency. So then we also tried with the phosphogypsum and red mud. We could able to do it the same thing. So that's what my first idea. So the second idea is the conversion of the bauxite residue into by the bioremediation process. So bauxite residue, it is produced by the aluminum industry. Now when we talk about the bioremediation, so we can use any of the microbe, fungi or the yeast or the bacteria. So yesterday we had an elaborate lecture on the bacterial usage, that is on MICP. In fact, we also made a small attempt so to convert sand into or to stabilize the sand using the commercially available the bacteria, that is Sparsiana pasteurii. This was our initial attempt, but this was not the final one. So let me briefly show. So this is the stabilized sand. These are the stress strain diagrams with respect to time and with respect to concentration of calcium carbonate. I'm not showing you all those pictures because yesterday we have seen enough, but that is not my objective also. So this is how we can able to understand the bonding of the particles, sand particles, the crystals of calcium carbonate. These are all crystals of the calcium carbonate by MICP process. And this is some kind of an scanning electron image or elemental analysis. Yeah. Now let me take you. So this is our core interest. Now here I'll be talking about the bauxite residue. So this is highly alkaline waste produced by the aluminum industry. Its pH is above 11. So it's not so easily amenable material because its pH is because of not only one factor. Its pH is repeated or regenerated by chemicals as well as the mineralogical compositions. So therefore, our ordinary thinking of pH decline will not work in case of the bauxite residue. And suppose you say that I have reduced the pH, then how it can rebound over a period of time. So that all let me also show you. Now here to neutralize the bauxite residue, so there are already several techniques available. So we can do the carbon sequestration or seawater neutralization or acid base neutralization technique or bioremediation or any other conventional additives. So here I am talking about the bioremediation process by the fungi, not the bacteria. So here we try to identify indigenously available what do you call the name of Aspergillus niger. So this is a fungi. So this is called as a filamentous type acid secreting fungi. So we identified surrounding in the local rivers or in the local premises, we separated it, then we try to use the same thing for neutralization of the bauxite residue. But how it works? So that's what the crux. Now the thing is that this bacteria, so it produces or it secretes different kinds of the acids. So like gluconic acid, oxalic acid, citric acid, so on and so forth. So just target. If my target is to produce the acids, so these acids in turn can react with alkaline compositions of the bauxite residue and thereby then they can decline the pH. So that's what is the fundamental mechanism. But for fungi to secrete the acids, we need to provide some kind of the nutrients, that is called as a broth media. So that entire thing comes under the microbe culture. Keep on feeding the broth media. So here we have used potato dextrose broth, which is commercially available again. So to initially culture the required quantity of the inoculant, then feed the inoculant into the bauxite residue. So we have done the various laboratory tests. We have prepared the inoculant and supplemented to the bauxite residue. But when we talk about the inoculant or the intensity of the broth, then there are again several factors. So these are some samples prepared by my PhD student. Yeah. So when we talk about the inoculation of the bauxite residue, so then how much percentage broth we need to add, and how long, and how much is the interval. So these are the different factors so that can govern. So whether you are literally doing the decline of the pH, or so you are ending up with something else. So these are all those results. So we have used 4 percentages: 10% broth, 15% broth, 20% broth, 25% broth, with different inoculation intervals every day, 1 day interval, 2 day interval, 3 day interval, and 4 day interval. So these are all some kind of the parametric variations. So now, so this is the previous graph, that is with respect to the percentage broth, while this graph with respect to percentage interval. Now let us try to understand. As I told, if you look at this graph carefully, so there are 3 fundamental forces. The initial pH of the bauxite residue is 11. So with inoculation, it was reduced to acceptable value, retained the same acceptable value for some time, but again it started rebounding. So that is the problem. So accordingly, you can name rate of decline or rate of rebound or neutralization period or so on and so forth. But here comes is the research challenge, because the fungi is available, so I can reduce the pH, but how do I address the rebound? Because once I treated with the fungi, again when the pH is rebounded to the initial value, so will it be acceptable for the practical usage, or what will happen to the leaching characteristics, or will there be any kind of a guidelines available to say that yes, once biotreated it can be used as a geomaterial? We do not know. So this is posing some kind of the research challenge, how to address the rebound issues, because the same can happen in all alkaline materials where the chemicals as well as the minerals are contributing for the pH. So this is other parametric variation to make understand how the pH is, or how much pH decline with respect to percentage broth, or how much the rebound is happening with respect to percentage broth. So all these so then same, so this is also percent variation. So rate of decline with the circulation period, or rate of rebound with the circulation period, or how long the pH is retained with the circulation period. So these are some microstructure images of the biotreated bauxite residue. So as such, there is no change, the morphology is remained as it is. Then the mineralogical studies. So can I able to see any kind of change in the mineralogy? But this fungi so is not harming any kind of the mineralogy of the bauxite residue. So one way happy, one way not happy. Because if you do not want any mineralogical changes, yes, this is a perfect solution. If you want the mineralogical changes, then you have to look for some other alternative. Yeah. So thank you so much. So these are some closing remarks of my research outcome. So as I told, so this as Professor D.N. Singh was saying, so neo-materials, it is not only the neo-materials, so but to produce the neo-materials, I feel we also need some neo-binders, or so neo-stabilizers. So like we can go for some kind of the enzymes, or some kind of biopolymers, or so we can integrate the enzymatic activity with the geopolymerization, or biopolymer with the geopolymer, so on and so forth. But otherwise, so everything works, but this is a very starting of my research. We have just started it. So thank you. So thank you so much for giving this opportunity.
Thank you, Dr. Hanmanta Rao, for the excellent presentation here as a keynote lecture. Thank you. Now we are going to the third presentation, and that is the paper presentation. I think that Mrunal Bokde is presenting it. Yes. Mrunal Bokde will be presenting on valorization of the landfill, mine soil-like fractions as an anthropogenic resource, challenges and opportunities. This session seems to be like Professor D.N. Singh's session. He has presented the keynote lecture, then his past student has presented the keynote lecture, and the third presentation by his student. So I give the session to Mrunal to present his paper. Please finish within 10 minutes.
Good morning all. I will be presenting on behalf of Dr. Goli and Professor D.N. Singh. So title of the presentation is Valorization of Landfill Mine Soil Extraction as an Anthropogenic Resource. What are the future challenges and opportunities in this aspect? So this is a term which has been discussed so much in the context of India, like biomining of landfills and some parts of Europe and China. So these are the mega cities which are hubs of huge legacy landfill waste. And like in Europe there are 500,000 of landfill, USA 150,000 of landfill. But India is also not an exception. We have also 3,000 dump sites and also active landfills about 300. This is one typical landfill site in Mumbai, which is these are legacy landfill and almost located near a water body. This is one of the landfill sites at Delhi, which is also located in near water body. So the question is how to remediate or how to go ahead with this legacy dump waste. So like Government of India has initiated a program like mandatory cleanup of this landfill site, and in this context we have started in India biomining of such landfills. So the way forward for such legacy waste is landfill mining. So this is a general typical segregation of landfill mine residue which is generated from the segregation activity, and generally we get soil like fraction. It's near about 60 to 70% of weight. So that can be so here a question is, as a civil engineer or geotechnical engineer, can such soil which are rich in organic matter can be used as a geomaterial or not? So if we go ahead with the classification of LFMSF, so will the conventional USCS classification will be valid for this such material or not? Basically we have given this classification for mostly for inorganic soils. So the way ahead for such a material could be physical and chemical classification or mineralogical classification based on the organic matter which is present in this. So the study which has been conducted includes collection of samples from 4 different dump sites, engineer landfills from India, different part of India, and the dependency of several physical chemical parameters. For brief, we are just presenting bulk density, how it is varying with organic matter that is present in the likely cation action capacity, ash content, also moisture retention capacity, how it is dependent on organic matter has been studied. So can this organic matter, which is a major component of such soil, can be helpful for soil conditioning? So majorly we also have basic soils which are basic in nature, acidic soils. So can this be used as a soil conditioner? Is a big can be thought of. So such like this you can get more insights from this paper. And now like idea was to establish this LFMSF as a buffer material. So herein like efforts were made to establish this buffer material. So the results were compared with acidic soil, basic soils and forest soils, So in this aspect, we can see LFMSF have higher buffer capacity due to its higher cut and action capacity. So now like one challenge here is such an result should be like sampling should be done extensively, and also should such studies should be established for several samples all over the globe. Now, if we are using such a soil which is also rich in microplastic, so microplastic which are adhered on soil particles or landfill mine soil extraction particles can leach out if we use it as soil conditioner. So this was a methodology which was adopted, given and patented. So herein to characterize several heterogeneous microplastic which are present in the landfill mine soil extraction. So a novel methodology was adopted, that it was scanned from USB microscope and in tandem usage with FTIR, and this has been patented. And to see the efficiency of such characterization technique or methodology, this has been compared, and we can see this like LFMSF, the technique which has been used shows like less error, so shows more efficiency in this regard. So furthermore, idea was to, can we encapsulate this microplastic in certain building material. So idea was to create composites out of it. So this is so the extruder, lab scale extruder which are existing in the current era, they are very costly, and also they are not designed for recycling heterogeneous fillers and polymers, and also the hardness of filler which are existing in the LFMSF or LFMSF itself may damage the instrument. So in this regard, this instrument was made and patented, which works on the principle of twin screw extruder, and this is patented. And so various composites were made out of it to study their tensile flexure strength. So there are several results based on characterization. Furthermore, this technology has been upscaled, and like to characterize these composites which are created thermally. So this TJ was patented, which can handle heterogeneous sample and more amount of sample for such heterogeneous material. Is patented, and these are some upscaling of technologies at one of the industrial sites in India. And these are the composites which are created, bricks and tiles. These are the building materials which can be used. And now focusing upon what are the research opportunities and challenges furthermore. So as a geotechnical engineer, we were not used to we are not supposed to use organic rich matter present in the soil, as far as ASTM code and IS code suggest. So one thing can be studied as we can establish the rate of degradation of undecomposed organic matter which is present in LFMSF due to thermal and chemical stresses, which will be if used as a subgrade of or embankment. And furthermore, establishing the compaction and compressibility characteristic of such material and how organic matter present in it can influence such characteristics. And just we are talking about the microplastic which are present in such material. If used as a structural fill material, how it will migrate when such type of stresses are acting on this material. Furthermore, idea is to study if such organic matter present in this get decomposed, then evolution of gases and leachate, how this will migrate through how such a matrix can be studied. And also thermomechanical heterological loading on such samples and response of that can be studied. And also such a material, organic matter rich material, can be used as an amending agent for several IBPs or byproducts such as dredge sediments and some red mud and all that can be studied. These are the future research opportunities and challenges can be studied upon, and these are the supporting agencies which were involved in this work. So these are some publications. regarding this. And I thank you for patient listening.
Thank you, Mrunal, for your presentation. Now, I would like to invite Professor N.C. Kotial. Professor N.C. Kotial is the professor at NIT Jalandhar, India. He will be presenting his paper on the topic of investigation of mechanical and microstructural properties of high-volume fly ash cement, nano-composites using Geo and CNT, a comparative study. Professor Kotial, please. You have time for the presentation is 10 minutes.
Good morning, everyone. I am Professor N.C. Kotial from Department of Chemistry. I am working on nano-composite with cement, especially the carbon-based nano-composites. This work we are doing for last 15 years. We have done in a various manner. But today's presentation is on, especially on investigation of mechanical properties and microstructural behavior of high-volume fly ash cement nano-composites using graphene oxide and carbon nanotube, a comparative study. The outline of my presentation is introduction, research objective, experimental program, synthesis and characterization of carbon nanomaterial, mechanical, microstructural and durability of high volume fly ash cement nanocomposites, and finally conclusions. This is a pictorial view of our campus at NIT Jalandhar. You can see many of you have already visited. Dr. Reddy has visited there. Professor Solanki has visited there. I think Dr. Singh has also visited. So those who have not visited, they can just, I'll just go through it. And you know that there are 31 NITs all over the country, one in one state. We are coming in the north part of the country and the Punjab state, and that also we are in the center of the state, located at around 100 kilometers from border of Pakistan. This is our entrance gate, another administrative building, another aerial view. And now I'll come to my presentation. This is my lab. So utilization of the fly ash can lead to development of sustainable and eco-friendly construction based materials. Low cost fly ash based construction materials, they are the front edge agenda of almost all governments across the globe, so that the low cost housing can reach to the common man. And a very few studies have been they are available on use of carbon nanomaterial on high volume fly ash blended cementitious nanocomposites. We have done several studies on without use of any fly ash on the cement carbon nanomaterials. But this study especially we have done because last time when I was in Chicago, somebody has asked me that why are you not doing this study on PPC? I am doing on OPC. Why don't you do it to PPC? So we started doing some work on PPC, and ultimately we have gone to the use of high volume fly ash in the cement matrix. So here we have incorporated graphene oxide and carbon nanotube as a compositing material at a very low concentration, that is 0.0005, 0.01, 0.02 and 0.04% by weight of binder, and the binder was fly ash and cement. And this study has included the test of compressive strength, tensile strength, electrical resistivity and durability of high volume fly ash cementitious nanocomposite. These are some of the limitations of the material, and we have tried to improve these limitations also. So why fly ash? Fly ash is finely divided product resulting from combustion of the coal in power plant. A lot of this fly ash is produced, which is a waste material, and it contains large amount of silica, alumina and a small amount of unburned carbon, which pollutes our environment. The particle size ranges from thermal power plant to thermal power plant, ranging from 1 to 100 microns. The Ministry of Environment, Forest and Climate Change and Government of India, they have issued a new guideline to the thermal power plant that they have to mandatory for them to remove all the fly ash within 3 to 5 years, not dumping it in dumping the fly ash in the landfills or water bodies, and pushing the industries towards eco-friendly utilization of the waste. And one such solution was with Dr. Rao also has given a presentation. So here you know that fly ash can be used at low concentration, moderate concentration, and high concentration, and very high concentration in the cement. But it is going directly to affect the properties of the matrix. If we are using it as a composite, if we are using it as a mortar or concrete, then it is going to affect the properties. So can carbon nanomaterial play some role in improvement of these properties? So that is what was the one objective of this study, because you know that the conventional composite materials, they cannot reach at nano scales. They cannot reach at nano dimensions, nanopores, and therefore these nanomaterials were used in this particular study. Over the years, I think the material scientists have tried to incorporate several kind of material in the cement, starting from coarse aggregate to fine aggregate to mineral additive to OPC to silica fume, and now reaching to the CNT and graphene, which are the best material as a compositing material. The two interesting thing here is that the particle size is reducing, on the other side the surface area is going very, very high, and that is what is going to give you some good results. So these two, there are two things. If you see geo CNT versus conventional reinforcing material, you will find that geo and CNT are having many properties which are better than that of your conventional reinforcing material. So this is my experimental program, preparation of geo from graphite powder by Hammer method, fabrication, functionalization of CNT and FCNT, that is functionalization of CNT into functionalized CNT, characterization of geo and FCNTs, and then fabrication of mortar composites by incorporating carbon nanomaterials, and finally we have tested them for various properties. This is the usual method of synthesizing the graphene oxide from graphite powder, and this is the method we have used for making CNT out of the toluene precursor using ferrocene as a catalyst. And this work has been done in National Physical Laboratory at Delhi by one of my students. There we have collected some indigenously synthesized carbon nanotube, because these materials are very costly. So how can we reduce this cost? And of course this method is a cheaper one. Then the functionalization was done in a usual manner. You can ask me that why are you converting GP into GO, or you are functionalizing it? You know that it is difficult to disperse this material in cement. So if you use very small amount, it is very, very difficult. So there are several kind of approaches how to disperse it. One is the use of superplasticizers. You can use the sonicator. You can functionalize these materials, then only they can reach. And these are the results which are showing that IR spectra indicate that yes, incorporation of the carbon oxygen moiety has taken place here. Now this is the XRD pattern where you can see that GP and GO, we have some kind of peaks which are coming at around 26 point. I'll just tell you. This peak is coming at 26.52, and interlayer spacing was 0.034. And what is interesting about here is that when you do the conversion into GO, the peak shifted to 10, around it is shifting to about 10.46, and the interlayer spacing, it goes to 0.84. What does it mean? That graphite is a sticky material. So when this sticky material is functionalized, you will find that there will be a exfoliation of the sheets, and this exfoliation is the point where we are interested, because this allows the crystal structure to form on this particular surface. We have not only done the work on the graphene oxide and the carbon nanomaterial CNT, but we have also made the hybrid of the two, and then we have seen that this hybrid material gives even better properties than that of your individual materials. This is what is a SEM micrograph, where we have seen that the large flaky type of morphology is converting into the exfoliated sheets. And this is what is proved by EDX, that yes, oxygen moiety has introduced in the molecule, both in CNT as well as in GO. This is what is the normal method in the civil engineering where the cement, OPC cement was used. Of course, the fly ash was used, which was collected from Guru Gobind Singh Thermal Power Plant, Ropar in Punjab, and it was utilized as a supplementary material, and it was replaced by 50% of the cement. So that means whatever cement we have used, 50% of that is replaced by the fly ash. The sand was usual sand, Indian standard sand, grade 1, grade 2, grade 3, and it was used in equal proportion, 1:1:1. Super plasticizer, Sika super plasticizer was collected from BASF, and the water was, normal water was used for this purpose, and the carbon nanomaterial we have synthesized indigenously. And by usual mixing,
You
1:3.
you may have to finish within 1 or 2 minutes.
Give me 2 more minutes.
Yes.
I'll try to finish. So, okay. So, these things are as usual, and these are the composites what we have prepared. In one place we have, you can just see that we have only OPC and carbon as a, you can say, reference material. Then high volume fly ash also reference material. Then in one case we have added only geo, increasing the concentration from 0.01 to 0.04. In the other case we have used the FCNT, that is functionalized CNT, from 0.0005 to 0.4%. The Sika superplasticizer was used uniformly, water was used uniformly. I will not go into the details of it, because you can just see that compressive strength by incorporation of 0.02% of geo, it goes high by 37% around. So what you can see here is that in case of high volume fly ash cement composite, you see there is a reduction in the compressive strength after 90 days of curing from 38 to 27, but by incorporation of 0.02%, it goes again high to 37.72%, which is a very good result. And then similar result has been obtained in case of your CNT also. This is what is the tensile strength. Here also you can see the tensile strength. If you add fly ash 50%, then it goes down from 4.78 to 3.03 megapascals, and it can be increased again by 0.2% incorporation of the geo to 4.9. So if you see the percentage wise the tensile strength, it goes up by 61.72%, and in case of CNT 45.21%. This is the usual micrographs, SM micrographs of high volume fly ash cement composite, as well as the geo incorporated CNCs, carbon nanomaterials, and this is what is the crystalline pattern. You can see that some of the crystalline materials, they are going up by incorporation of the carbon nanomaterials. This is what is the electrical resistivity. Electrical resistivity goes up, that means conductivity goes down, and it is increasing with the incorporation of 0.04% of the geo. Similarly, for FCNT it is going up by 25.75%, 76%. This is the sulfate attack studies and the acid attack studies. In the sulfate attack studies, what we have seen is that the material resists to the acid attack very well, and similarly on sulfate attack it is giving better results. So I'll conclude now. These are the conclusions. I have already discussed about some of these things. What I want to say in the last is that overall results have revealed that general inclusion of geo and FCNT in high volume fly ash mortar results in better compressive strength, better tensile strength, higher resistivity, electrical resistivity, high resistance to the acid and sulfate attack as compared to the high volume fly ash cement composite as a control. And geo-based high volume fly ash cement nano composites has produced better results as compared to the high volume cement nano composites. Thank you very much. These are some of our publications.
Thank you, Professor Kothiyal, for the excellent paper presentation. As Professor Kothiyal has pointed out in the starting that in India there are 31 NITs. Out of that, one of the NIT is Surat, where EGRWSC 2026 will held. And you all are invited for attending and participating in this conference, EGRWSC 2026 at Surat. Now I hand over the mic to Professor Krishna Reddy for summarizing this session.
I don't think we have a lot of time for summarizing. So I think it was an enlightening session. So I think we can continue our discussions with Professor DNS during the remaining day, and maybe challenge him with your questions. He likes challenging questions, and so it would be nice to discuss with him all the questions. And other presentations were excellent. So since we don't have much time, we have to move on to the next session. I think it's in the program. It is not. I don't know. It's a little bit probably confusing a little bit, but it's right here. It's right here. Yeah, right here.
Yeah.
Yeah.
So right now we
So-
would like to invite you to the workshop on the how to prepare the good quality paper. Here we are.
No, okay.
And before that, we would love to have a picture with obviously all the attendees of the main of the session, the speakers and the committee board.
Say something. Ask all the
Oh, yeah, Yelis, please come over. Santa, please come. Santa. Yeah, please come. Who else is there? Nothing. Please come.
उसका एडिटोरियल बोर्ड नंबर क्या होगा?
Alexandra, why don't you join us? Quick.
You come here.
Just one minute, please. One more guest is coming. Special appearance.
In the program it is not listed, so I think it's maybe confused. She's going to So hello everyone. So we're going to have a workshop on how to prepare a good paper. So everyone, can you move into the front, because there are a lot of empty seats in the front here. So it's going to be a very quick workshop. So please, please say 10 minutes. So, yeah. Can you please move to the front, please? I don't want to see like empty seats in the front. Should I say anything? Director. Yeah, what is your title? Editorial director for Asia Division? Or
Well, you can just say
Springer.
engineering and applied sciences, or just Springer
Yeah.
Nature is fine.
Yeah. You want to get your presentation? Is it your presentation is on? Okay. I'll just introduce.
Yeah, sure.
I think. Yeah, yeah. I guess I think it's there in the original one, but yeah.
You have to send me your presentation.
Yeah. I don't want to. Yeah, it's in my. So we'll start very soon. So please take your seats.
Russ.
Anytime you.
Okay, I think we're going to get started. So generally, we have almost 2-hour session for this workshop at other conferences, but because of the tight schedule of this entire program, so there are this whole workshop is squeezed into what? How many minutes? 20 minutes. So I don't want to waste too much time. So we are lucky to have the editorial director of Springer, Swati, and she has been a great supporter of this conference series. As you saw in my opening session, we have produced a lot of these proceedings books, and all the papers are peer-reviewed and they are Scopus indexed. So you can see a lot of papers published in this conference are being cited. So it's all because of our excellent support by Swati. So she's going to take it over, and as I said, she manages a big group, and she's involved in publications of a lot of books in engineering field. So without further ado, just to take away, Swati.
Thank you, Professor Reddy, and it's a pleasure to be back at EGRWSC as always. I don't think I have missed even one, and I'm so happy to be here and talk to you. I'm not going to waste any time at all because, as Professor Reddy said, we have 20 minutes. So we're going to do a crash course in research publication and scientific writing. Some of you might have seen some of the slides before, but I think there is always a new perspective because we have new people in the room. This is especially very important for young researchers who are starting to write papers and get stuck at different points while they're writing in their writing journey. Okay, I need to be closer to the computer, so I'm going to be here. I'm going to skip the introduction to Springer Nature. I think all of you know what Springer Nature does. And let's get started with the basics of research publishing, especially, as I said, this is important for young researchers. Can I ask how many of you have an ORCID ID already? Okay, pretty much everyone. Anyone who doesn't or doesn't know what an ORCID ID is? Perfect. We can move ahead. Then we're going to talk a little bit about ethics. Ethics come in before you start writing. So we are not only talking about publication ethics, we are also talking about research ethics, and they're quite deeply intertwined. You might have heard of a lot of cases recently, especially, websites like Retraction Watch track ethical transgressions in research publishing, and you must have heard that there are papers being retracted. You must have heard of something called paper mills. It's also very important for more experienced researchers who are, and senior professors who are running journals or are part of the editorial boards of journals, because these ethical conditions are often bypassed when we deal with content coming from unethical groups or what we call paper mills. Okay, paper mills basically just create unethical content which is not valuable or real research content just for the sake of publishing, and they sell it for money. So it's very important that we understand what are the ethical standards that we must adhere to as researchers. Everything that you see on the screen here is something that you should not do as a researcher. I'm not going to go into the details. Usually I spend about 30 minutes on ethics in my 2-hour workshop, but today I'm not going to go into the details of each of these points. But I do want to highlight a couple of new things that we are seeing now. It has always been the case that there are issues with plagiarism, there are issues with data manipulation, but now data manipulation has become a bigger concern because data and images can be manipulated using AI tools. And it's not always, because these tools are always evolving, it's not always easy for journals or editorial boards to catch what is happening, okay? So it's very important that if you are doing any sort of operation with any tool, now most of the tools that you work with, even if you're working with a CAD/CAM tool or MATLAB, many of them have AI capabilities built into them, right? So whenever you're using any sort of tool on your data or your image, please make sure that you declare it, yeah? You have to declare the use of any sort of operations that you have done on your data or your image, clearly stating exactly what you have done. The bottom line of ethics in publications is if you feel the need to hide something, it's wrong, yeah? So you have to make sure that you declare everything. If you have doubts or questions about whether something is permitted or not, read the guidelines of the journal or the conference that you're submitting to. Most of them will have ethical guidelines. If you still have questions after that, go to the Committee on Publication Ethics page, COPE. If you just type COPE ethics in Google, it'll take you to the COPE page, yeah? The URL is ethics.org. There is a lot of content there for authors, for reviewers, for editors-in-chief about how to handle specific ethical issues, okay? Then another thing I want to point out here is the last bit, citation manipulation. This point was not on my slide about 5 to 6 years ago. Yeah, when I was talking of ethics, I didn't need to talk about citation manipulation because it was present, but it was not rampant, yeah? But now we see a lot of concerns around citation manipulation. Can someone tell me what is citation manipulation? What do you think citation manipulation means? Yeah? Using the text without quoting? Okay. Any other guesses here? What is citation manipulation? Yeah?
Unnecessary self-citation and citing maybe your friend's work.
Okay. Unnecessary self-citation and citation of citations from friends and family. Friends and family discount, as we call it, right? So what the lady on the left said is not what we call citation manipulation. That would be a case of plagiarism or unethical or undeclared reuse of content. Yeah, so that would fall under that category. You're right, citation manipulation is manipulating citations, putting in citations that are not relevant, yeah, just to increase the citation of your own work, yeah, or somebody else's work. You're doing, it's usually a quid pro quo deal, you cite me, I cite you, or to improve the citations of a particular publication, okay. I'll give you one example. We had a case a few years ago where we received a whole proceedings manuscript, okay, around 120 papers. And when we get the proceedings manuscripts, we also asked for people to show us the peer reviews that they got done, right, the organizers. So when we looked at the peer reviews, one of my editors spotted a pattern that in every peer reviewer's comments, there was a request to cite 3 or 4 papers which were not related to the topic of the paper at hand, but they didn't belong to the editors of the proceedings, and she couldn't figure out why they are being, and they were all from different authors. And she was like, I can't figure out, there's something going on, but I don't know what's going on. And then we started looking deeper into it, and we found that all of those papers which were being recommended by the reviewers to be cited were actually published in one particular journal, and that journal was operated by one of the proceedings conference organizers. Okay, so he was doing this activity not to improve his own citations, but to improve the citations of the journal that he runs. Okay, so this was a clear case of not only citation manipulation but also review manipulation, because they had added these comments to the reviewers' comments, pretending that they were coming from the reviewers, right? So we had to just scrap the whole thing. We could not publish it anymore because the review process has been compromised. Now, when something like this happened, it's not the fault of the authors, right? They submitted their papers, everything was fine, but just because of this large-scale review manipulation which went on at the conference organizers, we could no longer publish that content because it's now compromised. So we have to be very careful also about the kind of conferences you're submitting to. What exactly is the review process they're following? Please be very, very mindful of that. Are there any questions? Because as I said, we don't have a lot of time. Do you have any questions around ethics that I can answer for you? Okay, so everyone knows everything here. So I'm hoping to see extremely clean articles for the proceedings manuscripts when they come in. So if you have questions, please feel free to raise your hand and ask a question. You can also find me later. But I do want to cover another quick point here, which is the manuscript structure, which is very important. I'm going to do a very, very short primer on the manuscript structure here. Ethics and manuscript structure are the two things that most researchers struggle with when they're putting things together. So that's what I decided to condense this 20-minute presentation into. Most of you are familiar with how a paper is structured, right? You start with the introduction, methods, results, and discussion. But exactly what goes on inside each of these sections is what makes or breaks a paper, okay? One very important thing that many researchers, especially young researchers, forget is when you're working on your research or experiment or simulation study, make sure you collect all of your methodology data, all of the information, even no matter how small it is. As small as if I'm using a scanning electron microscope, what is the brand and the model? Yeah? All of these things matter. So collect all your data. Make sure you collect and start writing about your methodology and the results you're obtaining as you go along with your study. You can edit and modify it later, but you make sure that you start writing so you don't forget anything. And always, always preserve your raw data because it's very important. Sometimes reviewers may ask for it. I've heard of cases even in the IITs where somebody had to do an experiment again. And I think there was a concrete curing paper just before this one, and this particular student that I was talking to was a concrete researcher, and he lost his raw data, and when the paper was submitted, the reviewers asked for it. He had to spend 8 months redoing parts of his curing experiments, right? So you can lose time, you can lose valuable data, so please make sure you preserve your raw data. There are now also options to load your raw data after you publish your content so other researchers can use it. if you are comfortable with it and your funder and your institution allows it, please do upload your raw data. That really brings the whole story together and helps other researchers build on your work. Okay? So you start by putting together a methods and results section. That's the core and it's the easiest to write, isn't it? Yes. And then you go to introduction and discussion. These are ideally to be written at the after you've selected the journal you're submitting to, because the journals might have special guidelines on how they want these sections to be structured. Okay? And be mindful, if your paper gets rejected from one journal, you might have to make changes based on the guidelines of the second journal that you are submitting to. Okay? So please make time for all these activities and don't get daunted or even hurt by these processes, especially rejection and revision. Yeah? If rejections don't happen, you know, everyone would be publishing in a handful of journals, yeah, if rejections didn't happen. So rejections are an integral process. They are intended to make sure that only very good quality, rigorous content gets published in high-level journals, yeah. And title and abstract are like the advertisements for your paper. So please write them once you have pulled the paper together. That's the best time to pull a title, because then it gives you a full picture of what the title should cover. So what should the title cover? The title should cover what exactly was investigated, what was measured, and the sample the measurements were taken from. Now, the sample doesn't have to be a physical sample. It doesn't have to be, a material. It doesn't have to be a water sample. It could even be a data set. Yeah? If you're doing a simulation study, it could even be the simulation parameters that you're using. If you're doing a survey study, it could be the information that you're getting from the people you surveyed. Yeah? But it has to clearly mention what is it that you're studying, what parameter are you studying, and how was it investigated. Try to keep it short, really short, like 20 words or less, and make sure you don't ask questions, describe your methodology, or use abbreviations or acronyms. Okay? Now, abbreviations and acronyms is interesting. Okay? It's because your abbreviation in your field could mean something else in another field. Okay? So I think the most common example I always give to engineering audiences is, do you know what SHM stands for? SHM? Okay, you have been in my workshops before, haven't you? Simple harmonic motion. Is there anyone else has another definition for SHM? Smart health monitoring. Okay, that's a new one. Structural health monitoring. Yeah. Structural health monitoring, since you're all civil engineers, yeah? Yeah, so you can see SHM, civil engineering, both mechanics related. Structural health monitoring and simple harmonic motion. But they mean two different things. If you put that in your title, how do you know if it's the people who work on vibrations that are looking for your paper, or the people who work on health monitoring of buildings and structures? Yeah? That's why it's a simple example to show why abbreviations don't work in titles, unless it's something very common like DNA or USA, yeah? Where it's very unlikely that there would be confusion. So please avoid abbreviations and acronyms in your title. And let's look at an example of a title. The top box is what a title should not be like. Okay? It reads like an abstract, and it actually is a title. It was a real title submitted to an Earth Sciences journal. Okay? And then once it's restructured, even though I am not an expert on geology, I can see what exactly is being investigated, measured, and the sample. In this case, the sample is a whole geographical feature in New Zealand. Yeah? Like I said, a sample doesn't really have to be a little sample in a bottle, yeah? Or something that can go under a microscope. A sample is whatever you are investigating or studying. Okay, same thing with the abstracts in terms of abbreviations. Please avoid them, keep them crisp. The easiest way to do a structured abstract, that's what we usually do in engineering and the sciences, is to get, write one line of intro, one line of your methods, one line of results, and one line of conclusion or discussion. That gives you a 150-word abstract. Yeah? Some journals will ask you for an abstract which is graphic in nature. And more often than not, I think we end up putting one of the images from our paper as a graphical abstract. Yeah, but try to be more creative. I think very soon, not right now, I think it's not the time for that at this point of time, but I see that in about 3 to 5 years, you will have tools that will take your paper and create a graphical abstract for it, yeah? Like an artificial intelligence tool. But think about how best to represent, if a graphical abstract is required, how best to represent the work you're doing in a particular image or a collage of images, rather than just putting one of your results images as the graphical abstract. Yeah? Keywords are also very important. Now, these are small things. You might think, why am I talking about these? But these are small things, but they're really important to who finds and reads your paper. Title, keyword, and abstract are always open. Even if your paper is not open access, it's always open. This is what search engines operate on. So to make sure that the right audience finds your paper, you have to make sure that all of your open elements actually lead the right audience to your paper. They're not generic, they are not vague, but they're very clear and crisp and intended to make sure the audience understands what you're trying to convey. So keywords have to be very specific. Again, we see an example here. You see the top box is a title, keywords submitted with that title by the actual authors, which are very, very generic. Molecules, lasers, optics, these are very broad terms. You shouldn't use broad terms. Instead, use specific terms and even phrases. So you see the third box on the screen actually uses little phrases which actually occur in the content of the body of the paper. So this makes it easier for the right audience to find it. Ask yourself this question. Look at this example and let's do an exercise. If you were looking for a paper on optical behavior of carbon nanotubes, would you search for it by lasers, molecule, optics? Probably not. Yeah? You will search for it by specific elements on the optical behavior that you are looking for or you are working in. So always put yourself in the shoes of the reader and ensure that these elements will help the reader find your work. There are 4 core sections, and we've been talking about them in the main structure of the paper. And the 4 core sections ask 4 core questions. Okay? If you remember these questions and keep asking yourself, is this section answering this question? Then your paper will automatically be structured properly. The introduction is the why of the paper. Why are you doing this study? How will it contribute to the state of knowledge in the field? What is new? Where is the gap that you will be filling with this particular study? The methods is how did you go about it? How will people know what you did? How will people replicate what you did? Because science has to be reproducible. And you all must have heard of studies being retracted because other researchers couldn't reproduce them. Yeah, so it's very important to put enough information in so that your study can be reproduced and built upon by other researchers. The results is the what did you find. So you wanted to do something to fill a gap in knowledge. You went about it doing XYZ steps in your method section. What did you find? That's what the results section is about. You describe what you find in detail. Usually we don't interpret what it means in the results section. We do that in the next section. But some journals will ask you to write a combined results and discussion section. In that case, you can describe your results first and then discuss them. Just break it up a little bit so it's easier for the reader to read the whole structure of the paper. The discussion section is very, very important. It's usually when I do workshops like this, I ask the question of what is the hardest section to write. And it's invariably discussion, followed closely by introduction. Yeah? So discussion is about, so you did all of these things, you found some results. What does it mean for the problem in the field that you started with, the gap in knowledge you started with? How does it make the state of knowledge in your research field better? How does it solve the problem? Or even how it does not solve the problem. That's also important, you know. And I'm going to just close, I think I have like about 4 minutes or 3 minutes left. I'm going to close with these slides. I know many of you are taking pictures. I'll also try to send you guys the deck via the organizing committee, so you have it at hand. I'm going to show you the 4 core sections, and I want you to pay attention primarily to the graphical structure of how a paper should look. So, introduction should start with a broad scope of what is happening in the field, where is the problem, and then what are you doing in this paper, only in this paper, to solve that problem. Those are the aims of your paper. Okay? Then we move on. As I said, methodology is important for 2 reasons. One, I already described, that researchers needed to reproduce and build upon your findings. But also, peer reviewers need to evaluate your methodology to see if it is actually the right methodology for what you're doing and if your results correspond to the methods. And here is an example of what the method section should contain in a lot of detail. I have also a sample here from a different field. This is an actual article, I think in one of the nature journals, from which we took this sample. And this just shows you exactly how to write a method section with all the details while breaking it up so it's easy to read and interpret by the reader. Okay, let's move on to the results section. Remember these 3 things. What do you have to report on? Initial observation, characterization of the initial observation, and the application of that observation to the problem at hand. These are the 3 things that you need to describe in your results section. Let's look at the example there. What did we do? We fabricated a new membrane for water treatment. We evaluated its physical and chemical properties under different pressures, temperatures, etc. And we found that the efficacy of the membrane in removing particulate contamination was 75%. Okay? That's like a short version of a results section. Another example here, which you can use, as I said, I would try to send the slides. Are most of you on the WhatsApp group? Then I can just put the PDF on the WhatsApp group. Yeah? I'll do that tonight. Okay, and let's look quickly at what figures and tables do. Very important to label all your figures and tables properly. Make sure the caption of the figure or table is where you describe it in detail. In papers, you should have long captions for figures and tables, because when people are reading, especially data-heavy figures and tables, they need to know what is happening right there. They shouldn't have to scroll up and down, yeah, or flip back and forth. So please make sure your captions are very detailed. You see in this example, they even have the little abbreviations they have used in the table. They have also explained them in the footnote to the table itself. So these little things matter a lot. Labels are very, very important. Sometimes you have labels, but they are not legible, right? Because the image came out of a software system and you never edited the labels, and now we can't read what exactly is going on in the figure. So please make sure you edit the labels to make sure they are readable, yeah? Finally, the last bit, the discussion section, okay? The discussion section, in the intro we started broad scope, went down to the narrow part of the problem and our aims. In the discussion section, we start with our results and then we contextualize them in the broad scope of the problem, yeah? So the discussion section is about how did you solve the problem. If you have not described what the problem was in the introduction section, and you have not described how to close, how you solved the problem or did not solve the problem in the discussion section, that's problematic. That's when papers become loose and vague, and then reviewers really cannot figure out what exactly are they contributing to the field. Okay, I'm just going to skip over this and then give you the full picture. So that's what your paper should be. It should start with the broad scope of the field, the problem or the gap in knowledge, work on that problem and gap through the methods and results section, then take your results and again contextualize them, explaining how you contributed to the state of knowledge in the field. And with that, I think we are done. I'm just going to close here. If you have questions, I'm around all day today. You can just come around and ask.
I know the next section is going to start in 5 minutes, so you should grab your coffee and go into room A or room B. Thank you so much, Swati. So she will give
Yes, a new PDF. I said
Welcome to the thematic session number 5, focused on geotechnical and geoenvironmental challenges. My name is Andrea Dominigliani from Politecnico di Torino, Italy, and I will chair this session together with Joanna Frankzik from the local University of Warsaw. So today we are going to attend 2 invited lectures and 3 presentations of papers. I'm very pleased to introduce the first lecturer, the keynote lecturer, Professor Ivan Paleologos. He is very well known to everyone working in the field of environmental geotechnics. He is professor at the Abu Dhabi University. He is the author of 5 books. One of the most popular textbooks for geoenvironmental engineering, Fundamental of Geoenvironmental Engineering. He is also the author of more than 150 papers. He is an expert in the field of groundwater pollution problems and broader environmental applications. So I'm very pleased to introduce you, Professor Ivan Paleologos, and I give him the floor, and please, Ivan, you can start your presentation. That is just only the title of the presentation, Geoenvironmental Challenges of Critical Minerals for a Clean Energy Transition.
Thank you very much, Andrea, and thank you, both of you, for the very nice presentation. I want to thank, first of all, the organizers, Dr. Krishna, who is here, for doing a tremendous job for the conference. Also, the university, the Warsaw University of Life Sciences, Dr. Eugenius and Dr. Magdalena, for putting a very interesting conference together. And most, okay, on top of that, apart from the big names, I would like to thank here Miss Alexandra for keeping us informed and being very prompt in her answers, and also all the other students and people that have contributed to the success of the conference, that didn't have the chance perhaps to know all their names, but you have all done a tremendous job. So congratulations to all of you, okay, on this successful conference. I wanted to take up the challenge that Dr. DNS put, okay, on some of the more philosophical aspects that we are, those of us that have worked longer in the field, which means that we are a little bit older than the rest of you, to put a more philosophical spin on, on some of the challenges we are having. And there have been a lot of buzzwords, sustainability, circular economy, and all that. And I'm afraid, from my part, that we sort of look at these concepts as the magic bullet that will solve all our problems. And my perspective, at least what I will present today, is that we're exchanging some problems that we have not managed to solve very well with a new set of problems that are going to be much more complex and at a different scale of what we are used to. And this is why I picked this topic on the metals that are needed for the clean energy transition. The clean energy transition, again, is also the big word, okay, that all economies are moving in this direction. So what I will present basically is that some of the issues that we are having, which are issues of quantities, the material that we need are going to be vastly bigger than what we have been using in terms of the metals. The complexity of the situation, I will present the complexity of the situation has to do with geographical distribution of the materials, the need for new mines in order to extract these materials, and the environmental problems that we are going to face in the near future. So what's the role of the critical minerals? Okay, the International Energy Agency has classified certain minerals as being very critical for the new economy. And this is sort of coincides also with the USGS list that have specified that five metals, these are copper, cobalt, nickel, these are well known, but also the less well known, the lithium and the rare earths that will be instrumental in the transition. The rare earths actually is not a single element, it's a family of 17 elements,
They are called rare earths not because they are not found easily, they are actually very dominant in pretty much in all the regions, but they are found in very small quantities, and therefore the extraction, the financial aspect of the extraction of these minerals is becoming very, very important. So here are some of the clean energy technologies. This is the wind turbine, okay? These are the elements that are needed there. Okay, you can see aluminum, for example, and we had Dr. Rao that presented the problem of bauxite waste in terms of the aluminum, and you can see, so with blue, the elements that I have highlighted that are more critical in terms of their mass, and also in terms of the neodymium, in terms of the rarity, in terms of finding this element. These are the mineral needs for solar photovoltaic. Again, you can see the dominance of the copper and the nickel, and we will see the quantities very soon. And the big, as they say, the elephant in the room is the energy storage system, the lithium-ion batteries. We are familiar with them in the small batteries that we are using across all the electronic devices. But also I wanted to show you a comparison that a regular conventional car has a battery that will weigh between 11 to 22 kilograms, where the electric vehicles require batteries of close to half to almost 1 ton of lithium. So clearly we are talking about getting a glimpse of the issue of quantities that we are talking about, and this is another graph that shows conventional versus electric car, and you can see that a conventional car, in order to be built, needs about 35 kilograms of metals, where an electric car needs 7 times this quantity. You can also see the comparison between the different metals that are required between traditional coal industry and, for example, wind industry. And if you can compare, for example, the copper quantities is significantly bigger. And the wind industry is also requiring, okay, a large number of other types of material, lithium, nickel, etc., etc. And the quantity, as you can see, for the coal is about 2,500 kilograms of material per megawatt of energy generated, where the offshore wind, okay, it will require, okay, almost 7 to 8 times more material than this. Okay, this is a breakdown of the electrical versus conventional car in terms of the minerals, metals that are required. Okay, you can see that the copper, for example, required for an electric car is more than double or what is needed for a conventional car. The manganese is also double, but also the electric car requires certain metals that were not part of the conventional car industry. Our smartphone that all of us are using is a very complicated machine, and no matter how thin we make it, you can see it is composed of a large number of metals here. With blue are the rare earth metals, or the displays pretty much depends on the rare earth elements. The microphone speaker the vibration unit of our telephone, of our Apple telephone, is also made of rare earth and nickel. And you can see the other metals that are required for the other parts of the smartphone. So we are dealing now with very small quantities of material, but material that a lot of them are toxic. So we are going to be, number one, we are going to be faced with a much larger quantity of waste, clearly. And number two, okay, with a much more complicated mixture of minerals that we will have to deal with them when we try to clean up or try to do something about that. Okay, so again, according to the International Energy Agency, okay, the rare earth elements demand is expected to increase by 3 to 7 times in 15 years, and lithium may multiply by 40-fold. Okay, so we are really at the beginning, as Davidra said, we are seeing a shift that is happening, a major shift that most of us and the public do not realize. We are seeing a shift, okay, in how the economies of the countries will operate, and therefore the type of problems that we will be facing. Okay, so we have the issue that we need big quantities of metals, some of them that had not been extracted. So what's the situation? Even copper, that is very well known, there are deficits that are predicted by 2030. So that already starts giving you some idea. Demand of lithium, okay, this is in 1,000 metric tons. The left one is 2020, which is already lithium had started being used a lot. 310 is the number. And now you can see it at least a 10-fold, 12, 15-fold, okay, increase by 2035. So we're talking about a very short period of time that, you know, the demand will skyrocket. And this is reflected also in the market, that from the 22 billion market is expected to jump to 134. So it's a 7-fold increase in a very short period of time. Rare earth elements, the same story. Again, there are major deficits that are anticipated for the rare earth elements, and that will mean some things for the electronic equipment that we are using. And this is another very interesting statistic from the World Bank that compares the baseline is 2018, and then the World Bank, what it's doing is estimating what is the percentage increase demand for different types of minerals. So you can see graphite, 500% increase by 2050. Lithium close to this one, cobalt 450. So you are talking about, you know, tremendously big changes in demand on some of the minerals that some of them are mined, but the quantities, as you saw from copper, are not sufficient to meet the new economies that are emerging. And some of them did not used to be mined because we didn't know the properties, we didn't have the technologies, okay, that will take advantage of these metals. And of course, okay, this has led to the search of new mines. I want to remind you that in most cases, you know, from exploration to exploitation takes about 10 to 15 or 20 years for new mines to be in production. So we have a lag here. This is a rare earth elements mine in California in the United States. And I think some of the speakers and Dr. DNS alluded to that. This will create some geopolitical tensions because you can see already that Bloomberg said that US needs to do something about Africa, okay, and the fact that Africa has a lot of these minerals that are needed for the new technologies. This is a picture from EU. EU has a directive on electrical and electronic equipment. This covers a broad spectrum of equipment from our refrigerator, dishwashing machine, okay, to even electric toys and electronic things that we are using for exercising at home, okay. You can see how many new materials that were electric and electronic got into the market. And you can see, for example, in 2012, the number is, you know, close to 7,500 tons, and this number has almost doubled in 9 years from into 2021. You can see that roughly 1/3 of them is collected, so the rest, you know, we don't know how they are disposed of or they go. And from this, even a smaller part gets to be treated or recycled, or we do something about that. So again, we have an explosion of material, we have an explosion of equipment that, you know, we are putting in the market that we don't have the answer of what to do with that. Mobile phones, and this is an example from UAE. So, okay, there are some campaigns and there's a big success that about 60,000 mobile phones were recycled until the end of 2019, which is a very good effort, but, okay, to put things in perspective, in 2022 there were 7 million, okay, that were sold that year in that country. So really, you are talking about an infinitesimal amount of recycling that takes place. And of course, okay, you have environmental problems with e-waste. E-waste sometimes are sent to countries that are poorer, that they need, okay, the capital, okay. And this is a case from a province in China. This province, okay, occupies about 100,000 people that work in disassembling and recycling the waste. The problem was that, okay, they found out that the cancer rates had increased, and lead and other material had seeped into the ground. I'm trying to give an overview, okay, of some of the problems that we'll be facing with the new technologies, okay, that of course are needed to address the climate change and CO2 emission, all that, but on the other hand, they are coming with their new type of problems. So to become more specific, we have a problem with the geographical distribution of these critical minerals. So what do we do? What do I mean by that? If you look now at the different types of metals, cobalt is found 70% in the Republic of Congo. Okay? Dysprosium, which is a rare earth element, is found in China to 50%. Actually, China dominates the lithium also. The lithium market, 70% of the lithium is coming from China, and therefore this creates an issue for other economies because of monopolies and all of that. South Africa is a prominent source for different types of metals. You can see it in manganese. Nickel is Indonesia, 50%. Australia, okay. Nickel is there. Copper, Chile and Peru and Bolivia, these South American countries had traditionally dominated this metal. You see iridium is primarily coming almost to 90% by South Africa, and then you see some other, and platinum, the same thing, also from South Africa. So, in a nutshell, what is happening is that we have a major shift of where the really critical resources are found in terms of the reserves. We have a very big shift, which a lot of them, which means that the developed economies have the technologies, have the capital, they have the resources. The reserves are found, though, in poorer countries, primarily in Africa. They don't have the technology, they don't have the capital, they don't have the infrastructure for that. So that clearly creates some kind of difficult situation of what the future will be with this extraction. Now, in terms, to connect it to my, one of my expertise, extraction requires big quantities of water. Okay, so here, for example, 1 ton of lithium requires depending on the process, requires from 500,000 liters to almost 2 million liters of water to extract. Some did some small analysis. Okay, in the region that we are talking where this extraction was taking place. The per person per day consumption of water was 50 liters per person, so that corresponds to extract 1 ton of lithium. This corresponds to between 10 to 40,000 people water per day. Okay, and now water is a scarce resource in many of these regions, and you, on top of that, apart from the mining, you also have other industries. You have also the drinking purposes. So clearly, we are going to have a competition for the water reserves between the different industries and the new mining that will be needed. Interestingly enough, when I showed the distribution of where these metals are found, they are found also in countries that are water stressed. So, South Africa, which you saw, is 90% palladium and other things, and all of platinum and other things. Okay, you can see that it's ranked, as an extremely high water scarcity region. Okay, Chile, which is top in country in copper and other in lithium and etc. Is also found in the extremely high water stress region, and the list goes on and on. That in many cases, or actually in most of the cases, where we have these reserves, these metal reserves, these would correspond to places that really the water that they're having is very, very scarce. So we need to do something about that. In Chile, they are trying to do, in some cases, where they can desalination, desalinate water, but that also has its limits. So I will skip that part. Okay, so environmental concerns. Okay, I'm not going to go through the processes. There are different processes, for example, for copper and all this. Bottom line is that, and there are people from the university that spoke about the waste tailings. There are acids that are required. First of all, there are big quantities of material that's extracted, in order to get a few grams of a metal. So you have a problem of the material, how to dispose it, but also during the processing, in order to free up this metal, you also need some acids in order to do the processes. So that has created problems, and you can see, for example, this is the lithium mining that takes place in Chile. So what lithium is also known to be highly toxic, and the way the process is done in order to extract it is that you pump water in holes, okay, and you start taking out ores, okay, and you try to process the lithium. And now all of this water that is mixed with different chemicals becomes the mine tailings, the waste, okay, the liquid waste, and this is stored in ponds, as you can see, at the location of the mine where it's evaporated. If the mine operation is also modern, then, okay, some of this water may be cleaned up and recovered to be used in the process again. Okay. Okay, these ponds have dams in front of them. Some of these dams reach several tens of meter height, and there are issues of stability, geotechnical issues, that how to make this dam hold of this material. They are pretty big, as you can see from this picture. The satellite pictures also can be pretty. This is the lithium ponds that you can see all the colors, but the colors represent different pH and different acids that in the different ponds that you see here. These are some mounds of lithium in Chile, again, some picture there, okay? And now what you see here, this is the San Marco mine in Brazil, and you can see the mine is over there, and then basically the liquid waste goes into this pond down there. You can see that it has this orange color. I'm showing this picture to make the point that some years ago, in 2015, the dam collapsed. So you can see that 33 million cubic meters of this liquid waste got freed up. Okay, if you look at the picture up there, you are going to see the names of some rivers there. Okay, so this liquid waste moved through the surface water system through the Doce River, and was, after 650 kilometers, was released in the Atlantic Ocean about 17 days later. And this is a picture that I took, okay, about a month after the accident. And this is a picture that is, a more recent picture. You can see the difference, okay, in that the mouth of the river and the Atlantic Ocean has not cleared up for all of this, okay, toxic material that was released in the system. This destroyed several villages, obviously created a big ecological catastrophe in the region. Okay, so this is, okay, to show that, okay, with the explosion of the new mines that will be needed, we will be facing some very, very critical and pressing environmental problems, okay, that somehow we need to come up with solution. And then, okay, I wanted to bring up even, as a side note, okay, something that some of us may not have thought about, that the Bitcoin, that, it's a hot item, okay, for investment and all that. A lot of countries are jumping the bandwagon, and the UAE, the Arab Emirates, this is the locations of mining facilities, okay? And basically mining facilities needs also a lot of cooling that will take place in these facilities. And the cooling requires water. So this is the number of water that is required for this cooling facility that, okay, represents about half of the required per year quantity of water for UAE, which is obviously a very desert country with less than 100 millimeters of water per year, that the water depends completely on desalination. So these are, okay, some of the major issues that we will be facing in the coming future. And when I say coming future, these things are becoming very urgent year by year. So we don't have really a 10 or 20 year period time for us to be reacting. Some modest recommendation, okay, obviously the mining operation needs to be improved vastly. There needs to be very detailed studies of the water management in the region, because we are talking about, okay, in many cases of water scarce region. The environmental protection, you know about cases like acid mine drainage and all of this. Environmental protection of the mines need to be put in place. The technologies that we are having need to be vastly improved. They need to be much more efficient. Okay, the whole operation needs to be much more environmentally friendly. And now, okay, we need to do something about reusing and recycling. Although, as I showed the picture from China, okay, we have issues, okay, of with the cancers and all of that. I want to bring to your attention that some of the metals, for example, copper, a big percentage of the metal is recycled and it is back in the market. Okay, but for example, for lithium, there is almost zero recycling. There are only 32 companies in the world that are doing recycling. Most of the technologies, they are patented, so they are not, really even public domain. It is really at the very beginning of it. Rare earth elements is also the same story, that we can put a zero in the recycling efforts there. So this is clearly something that we need to speed up tremendously in order to bring some of this material back into the market. And this is my last picture, okay, of what things used to look and what some of us hope also to look at some point. Thank you very much.
Thank you very much for a very, very interesting presentation. Maybe, yeah.
Okay, so I'm going to introduce the next invited speaker, Dr. Milind Kire. He is a professor of civil environmental engineering at the University of North Carolina in the United States. He holds a PhD from the University of Wisconsin-Madison. After obtaining his PhD, he had some work experiences in the United States and New Zealand before joining the Michigan State University. And after 12 years at the Michigan State University, he joined the University of North Carolina. He is the recipient of several awards, such as the Cross Medal and the Outstanding Service Award from the American Society of Civil Engineers. He is the author of more than 120 technical papers, and he is an active member of the American Society of Civil Engineers. So I'm very pleased to introduce his guest lecture, focused on elevated temperature landfills. What do we know and don't know? Milind, the floor is yours.
Thank you so much. Thank you, Andrea. Can you hear me okay? Yeah. Okay. I just want to make sure it's on. So how many of you heard about elevated temperature landfills? Please raise your hand. Okay, good. So not that many. So the landfills on fire versus elevated temperature landfills are quite different things. I know Magdalena mentioned in Poland there are landfills on fire, she said. In India there are several landfills on fire. Those are landfills on fire, different than this. This is a little different problem. This is even for line landfills, which are big landfills, typically big landfills. In US, there are about 15 landfills which are in this category that we know, and there are about 30 going to be declared ETLF in the next 3 to 4 years. And I'm going to give you an idea of what's going on. What are these landfills, exactly what we know. Everything hasn't been figured out. I want to thank the project team members. Waste management is one of my partners, and I have instrumented several landfills where we measured a lot of temperatures and many other variables to be able to make some understanding. We have not 100% clear now on what is exactly causing it, but we kind of have a theory what's going on. What are ETLFs? So I know many of you did not raise your hands, but ETLFs, the definition is not very specific, but generally speaking, if you talk to the people in the industry, you're going to see these items they'll bring up usually. One is typically if you look at landfill waste temperatures, and I'm talking about landfills which are lined landfills where waste is compacted every day. Okay, waste is compacted every day. There the temperatures will reach anywhere from 150 degrees Fahrenheit to 180 degrees Fahrenheit in the peak. Now I'm sorry, I'm speaking in degrees Fahrenheit, not in degrees Celsius here. I know there is a lot of degrees Celsius crowd here, but if you can translate that, that'll be great. So gas gas wellhead temperature. Modern landfills have gas extraction wells. The wellhead, which is on the top, that's where they measure the temperature. It's hard to measure temperature in the waste unless you put sensors, which, I have several projects, but you can't do it at every landfill. But in the US, you're required to measure temperature at the wellhead. The wellhead temperature, when it exceeds 131 degrees Fahrenheit, it's considered too hot at that point, even though it's not an ETLF. But when it goes above 150, that usually means the waste temperature is about 180 to 190. Because if you take the wellhead temperature at about 30 to 40 degrees Fahrenheit, you get the waste temperature empirically from all the observations, okay? So waste is already at 190. Boiling point of water is 212 degrees Fahrenheit, just for reference. That's one indicator, but that's not, these all indicators have to fall in place, not just one, okay? Methane to CO2 ratio. Most landfills, when they are producing decomposing waste, anaerobically, they're producing 50% methane, 50% CO2, roughly speaking. So the methane to CO2 ratio is 1 to 1. ETLF landfills, the methane starts falling off. CO2 starts increasing. You start generating carbon monoxide. You start generating hydrogen. You start generating some other trace organic compounds which you do not see in regular landfills. And the landfill starts really stinking. If you've been to the ETLF landfills, they smell like baby puke. It's not a good smell. You have to change your clothes. You have to take a couple of showers, and you still smell. So it's very unpleasant because there's clearly some chemical reactions going on. These are not aerobic reactions. These landfills do not contain oxygen. They are not on fire. The waste is heated up. It is not, there is no flames in the landfill. It's very hot. It becomes like charcoal. It's almost like a pyrolysis, but it's not pyrolysis either. And there is a lot of leachate generation. The waste starts just kind of like cooking. If you put beans in pressure cooker, how many of you use pressure cooker? Uh-oh, not many of you cook. Okay, what do you got? You get pizza? Microwave dinners? All right. Okay. If you cook beans, they're hard in the beginning, right? And you can keep boiling them. It will take forever. If you put in a pressure cooker, as soon as you hit that magic 212 degrees temperature with atmospheric pressure increasing, the boiling point goes to 250, higher temperature above boiling point, boom, they suddenly soften up, they get mushy. That effect. So the landfill becomes a pressure cooker. That's the theory. We now finally kind of confirmed the temperature has to reach 212 in the belly of the waste for it to start cooking, and that's when the smell starts coming. Okay. BOD increases, COD increases, and some landfills are at 300 degrees Fahrenheit, which is very, very high. So these landfills have water which is actually at super temperature, which is above 212, but under pressure, like in pressure cooker, you can have 2 atmospheric pressure and the water doesn't boil, because it's basically increasing the boiling point. But as soon as you open the pressure cooker, you got the steam coming out, right? The steam hisses out. Same thing. So these landfills, they're inside the deep one. They're usually very hot, about 2/3 at the depth from the top, okay? So 1/3 from the liner is the hottest temperature point, usually. And they're so hot there, when you start making a hole in the landfill to extract gases, because they're smelling, they're trying to extract gas, trying to extract liquid, usually you get a geothermal type of a geyser coming out of it. It's just like the steam coming out of a pressure cooker. You get the leachate start shooting out of the landfill, It looks like a steam, okay? So it's pretty serious stuff, because when that temperature goes up, you're worried about your liner. A lot of safety concerns, infrastructure challenges. You're going to have landfills settling all the time. You cannot really go, I mean, literally you can have a depression as deep as this room formed in literally a day in the landfill. So you can, it's very dangerous to be on these landfills. They put fences, they put temporary geotextile caps on them so equipment can ride. And it's an extremely serious situation. And this happens with usually wet landfills and usually landfills which are big landfills. It doesn't happen with tiny landfills. It doesn't happen with landfills where the waste is thin, where you don't compact much. It's not going to happen. You need compaction, you need enough carbon in the landfill, packed tightly, and you need enough liquid going through the landfill or accumulate in the landfill to make this happen. Just to give you an idea, in the United States, landfills produce leachate at about the range is east of Mississippi. Mississippi is roughly in the middle where the white contour band is. That east of that is wet conditions, more rainfall. West of that is drier condition. So the landfills on the east side usually produce an average about 300 gallons per acre per day. That's the leachate production. I know, again, I'm talking gallons per acre per day, but about 300 is an average number. In Florida, it's about 500-600. You go to Minnesota, it's about 200. New York, about 400. You know, so it varies, but generally 300. If you go to West Coast, about 10 gallons per acre per day. Huge difference, right? 1 order difference. What I'm referring here is the convective cooling. So what is strange about this is the landfills on the dry side, very hardly any ETLF landfills, hardly any hot landfills. There is not much moisture in them. And if there is some ETLF landfills, a portion of the landfill which is very wet for some reason, because they took wet waste, they took biosolids, or something happened, is the only portion which is hot. So that water is a fuel. But water is also a cooling media. It's a double whammy. So if you don't have enough water, you can actually, there's no convective cooling. So the landfill on the east side, definitely more ETLF, more liquid, but those landfills are not flowing. There's a lot more liquid going in, but not enough coming out. So the waste liquid accumulation is a problem. When you accumulate liquid, that creates reactions. That's what we're finding now. If it's not flowing enough to leachate collection system, you do not have the heat removal. And the gas, heat removal from the gas is very minimal because gas doesn't have much density. If you look at a gas generation curve from a landfill in wet climate, this is your typical gas generation curve for a landfill. The green line is for wet regions, red line is for dry regions. So for wet regions, you can have a much higher peak, but the carbon will be depleted sooner. Versus for dry landfills, you have the reactivity is less because there's not much moisture. Because moisture is the fuel. Moisture is what causes methanogenesis. Methanogenesis does form heat, by the way. So if you look at some numbers here, I'm just going to give you some idea of the heat generation. So 1 cubic meter of MSW, okay? This one I have it in meter cube, by the way, not feet cube. But feet and meter cube are about the same. So what we found from the measurements we have done in the field now, the waste generates about 0.1 to 1 watt per meter cube of heat. On the dry climate side, it's about 0.1 to 0.2. On the wet side, it's at 0.5 to 0.6. When it reaches 1, it is extremely high. So the ETLF landfills, the waste is producing about 1 watt per meter cube to raise those temperatures. Just to give you an idea, 1 watt per meter cube is usually, a watt is equivalent to a Christmas, light bulb you've seen. That's about half a watt. So we talk about very tiny, but when you look at the landfill mass, so like the size of this room, you can only generate about 50 watts or something. It's not much. But when you look at the landfill, millions of tons, that adds to be a lot of heat. And that heat means a lot of accumulation of heat, increased temperature, if you do not have enough losses. So this is your landfill here. You got heat generation happening in the middle. And the removal of heat is to the atmosphere by conduction. You do not, and of course, gas removal, which is very small. Or when you collect leachate down there, you got convective removal. And also you have conductive removal through subsurface. The subsurface is your heat sink because usually the ground temperature is usually fixed, right? It has enough heat absorptivity. So the heat generated in the landfill is not dissipated enough, the temperature is going to rise, okay? And that's where you get a lot of temperature rise. Just to give you an idea, the aerobic, if you have a compost pile, or if you talk about the landfills on fire in Poland, in India, in Philippines, in many places, the aerobic landfill, you're generating about 17,000 kilojoules per kilogram of cellulose. That's what aerobic reaction generate. In a landfill, when you look at a landfill here, typical MSW landfill, we're looking at about only 340 kilojoules per pound is about roughly the heat generation. So it's very small compared to this 17,000 kilojoules per kilogram. I know I got the units not exactly consistent here, but roughly speaking, you can convert it. 17,000 versus 340 is one order difference here. So clearly these are not generating heat at the rate of aerobic conditions, but enough that if it accumulates, you can have serious temperature conditions where the boiling point of water is exceeded. You can have smells, you can have settlement, you can jeopardize your liner. It can make your life miserable. If you're a landfill operator, it can make things very expensive for you. And the neighbors are going to complain about you every day for the odor. You'll have to shut down the landfill. Okay. So at several landfill sites, I have instrumentation systems installed which look like this. So I have fiber optics arrays and I have thermocouple arrays, depending on how remote the site is and what kind of devices we have to get the data. And looking at different measurements from humid to dry climates, I have generated temperature profiles for many landfills. So this is the temperature profile I was talking about. This is a normal healthy landfill. So far it is not ETLF. This is peak is about 180 degrees Fahrenheit. And you can see the age of the waste varies here from 5 years to 9 years. And there's not a whole lot of difference. And you have landfills with really old waste, 20, 30, 40-year-old. And there the things are cooling down a little bit. Okay? But this gives you a humid landfill one, humid site. The belly, usually the belly is in the middle, 1/3 from the bottom or 2/3 from the top. And when the belly is very pronounced, like the beer belly is pronounced, that means there is a lot of liquid moving through, causing convective cooling. When the belly is flat, there's not much liquid going on because the liquid moves the heat down and the optimum point is at 1/3 from the bottom because of the way the boundary conditions are set up in the landfill. Okay? All the modeling we had done, a lot of 3D modeling we had done on many landfills, and we're able to confirm this hypothesis. This is another landfill. See the same pattern here, 1/3 from the bottom. This contains coal ash actually here, old coal ash, which we thought could be hydrating. Not really, because the temperatures are very consistent with MSW landfills. This is mostly ash, much more ash, less than 4-year-old. You can see much hotter, but not enough. So that if there's a hydration of ash going to happen, it's going to be very quick heat. It will be released very quickly. So ash is not the reason for ETLF, is what we ruled out from looking at number of landfills. It's not the coal ash that you took could have been causing the problem. It is not the aluminum dross which was creating the problem, because aluminum dross has been brought up a number of times. Aluminum, when you oxidize it, generates enormous amount of heat. It's so big, it will be almost like 5-6 watts per meter cube of waste. That the landfill will almost explode in that condition. So we ruled out that. So we do not know exactly what, but we have ruled out many things, if that makes sense. Because sometimes you cannot find a straight solution, but you can start eliminating what are the possibilities. This is a dry landfill. This is a dry landfill located in the dry region I showed you. Temperatures are much lower. You can see that 140 is the peak here. This is about 1 to 4-year-old waste. Now when the waste gets older, slightly higher heat because there's more moisture generated during the methanogenesis, that feeds the heat. But still we're looking at 140, 150. Versus when you look at humid climate, you looked at 180. You see the difference there. Okay. This is 25-year-old arid site here. Very old waste. We're looking at about 110. As the waste is getting older and older, it's down on that gas generation curve. So a lot of carbon is converted to methane. And you can see the temperature is dropping. Classic anaerobic, heat generation or gas generation. So what are the key differences? I'm not going to go through every variable here, but what I want to show you is healthy landfill versus elevated temperature landfill. There's a comparison we have developed based on a lot of data we collected from number of sites. You can look at the wellhead temperatures, which is the first one I listed here. The wellhead gets very hot at 200. That's your first alarm. You got something going on in the waste. You got to really start putting in sensors to figure out where is the region which is hot, because the gas temperatures only give you a broad idea. It doesn't tell you in the landfill's heart of the landfill what is going on. You got methane. You can look at the methane percentage here. That's the third variable here. You can see usually healthy landfill is about 50%. And remaining is carbon dioxide, right? Well, it drops below 25%, which itself is a problem because many of these landfills are counting on gas to energy. So when you lose methane, you're losing your resource, and you got other problems down the line. So then you start getting hydrogen. Hydrogen usually in landfills is 0 to 2%. So it's not like there is no hydrogen. When the hydrogen goes to 15% or above, that becomes a pretty serious problem because hydrogen is an explosive gas. Okay? So there's a lot of OSHA and regulations kick in, which do not kick in otherwise. And I can go on. The TDS goes up. The leachate, the BOD goes up. The smells go up. Leachate production, 400 to 800 for humid climates, it'll drop to thousands of gallons. Some of the landfills I know are producing right now almost like 5,000 gallons per acre per day, and that ETLF, because the waste is just cooking like a pressure cooker. It's like a pressure cooker, literally. So this is the data from one of the sites. You can see here, this landfill, the red circles are methane. You can see the methane is going down, CO2 is going up. That means this landfill's ETLF journey started. It is already an ETLF. It has lost its original chemistry, and new chemistry is kicked in. And you can see now the other gases are being formed. Carbon monoxide is increasing. Balanced gases, what I'm talking about balanced gases, that's your hydrogen, and that's your carbon monoxide. That's increasing in the landfill. Wellhead temperatures. We looked at what can be an early predictor for this landfill. So the owner is prepared that I have an ETLF on the way. I need to do something. Wellhead temperature, if you map the data over time, it will start increasing trend. You're going to start, so data analytics you can start using like an AI almost. You can start putting trigger values. If you got a cluster of whales, start averaging at much higher temperature, you got a problem. So you can do that. If these lines are flat, there is no increasing trend, obviously you don't have an ETLF. This is the average of these wells I showed you. You can see the wellhead temperature has reached 200 degrees Fahrenheit. This should be below 150 usually. So I just drew something for you to take away. I'm finishing up on my time in 2 minutes here. We're at 18 minutes mark. I want you to imagine a pressure cooker. I really like this pressure cooker idea. When everything clicked, after I seen a lot of data now, I realized why these landfills produce so much leachate, why they stink so much. That cooking phenomena comes in is a pressure cooker. Imagine a pressure cooker which is 100 feet high. I know pressure cooker is only a few inches high. 100 feet high, I'm boiling, I have the lid on it. Of course, there's a lid on top. There is no lid in this picture here, but there's a lid on top. I'm heating up this column of water, and once the water temperature reaches 212 here, actually, this is not a pressure cooker. Sorry, let me take that. This is just an open container here. This is not a pressure cooker. Just think about open container like I have. When the water reaches 212 here, it's going to be, the bottom is going to be at 290. Do you know that? It's not boiling here at 290 because of the pressure of the water. Because 100 foot of column is enormous pressure. So you just raise the boiling point of water here. Now, when I put a lid on it, I can even increase this temperature to even further. So in landfills, what's happening, there is no lid, right? I mean, you say, where is the lid in the landfill? There's no lid. But you have perched leachate zones in the landfills. The landfills we found ETLF have perched leachate 50 feet high, 60 feet high, 100 feet high. Is sitting on the low conductivity layers. And the heat is being generated. If it's not dissipated, you got water above boiling point of water. So when you put a hole through the landfill, when you drill a well, that water which is high temperature just gushes out like a geyser. Okay. I talked about organics in the gas well leachate. You see all sorts of organics when the landfill becomes an ETLF. They show up. Causation, potential exothermic reactions at play. Well, do we have aerobic degradation? But this is impossible. We didn't think aerobic is possibility here. Anaerobic degradation is what we think it is, right? But not really, because anaerobic temperature will keep the landfills below 180. Because the bacteria which generate the heat, they cannot live at beyond 180. So it's definitely not anaerobic. Anaerobic may be the beginning, but it is going into some different mode. So we really haven't figured out what reaction mechanism it is. CCR or MSW ash hydration carbonation, probably not. We ruled that out. Metal corrosion, hydrolysis, probably not. Water gas shift reaction is what we are heading at. That is more likely the phenomena which is kicking in at some time, which can generate a lot of heat and kick the temperature higher level. Water gas shift reaction. If you Google that up, you will see that is most likely what may be going on, is what we are hypothesizing at this point. This is just the heat generation rate, just for your takeaway. I'm at the end of my presentation time. If you're looking at a landfill, if you're going to model a landfill in a humid climate, what you're going to find, the fresh waste is generating 1 watt per meter cube for a very short period of time. Typically drops off very quickly into a half watt range. And as the waste gets older and older, the heat generation drops to 0.1, 0.2. In dry climates, you're very low to start with, and you're going to be lower than that. So if your landfill is producing higher than these values of heat, you're an ETLF landfill already. You got to do something to cool it down. These numbers we're using as a database for figuring out if this landfill has a potential to become ETLF or not. So key takeaways, well, I think I basically have talked about all of them in this. I don't need to summarize this. I mean, you can just read the summary. I'm at the end of my time. I want to keep this on time here. So thank you so much for your time.
Yeah, thank you very much for very interesting. Yeah, I would say that the processes were okay.
Oh, for me, I present. Okay. Well, thank you so much. Thank you so much. Yes. Oh, sure. Yes. Yes. Oh, down here. Yeah.
Okay, so now I would like to invite Irem Zeynat Ildirim to present the topic feasibility of glass power replacement to alleviate swelling to steel slag, long-term swelling and microscopic observations. The floor is yours.
Thank you very much, everyone. First, I would like to thank the organizing committee for this great event and the students who participated. I can see them. It's my pleasure to present here. I'm from Boğaziçi University, Istanbul. Basically, I'm a faculty there, and today I would like to discuss the feasibility of glass powder replacement to alleviate swelling of steel slag. I will talk about long-term swelling and some microscopic observations as well. So this is the outline of my presentation today. I would like to just give you a brief background. Slags remain to be one of the main waste streams in most steel-producing countries, China, USA, Turkey, and we still have to find applications for these stockpiles of materials. And I have done research on a lot of different types of steel slag, but today the focus of my research is basic oxygen furnace slag, which are basically basic oxygen furnaces are always located in integrated steel mills together with blast furnaces. This is like a granular material. The main issue with this material is its swelling potential. And main sources of volume change come from calcium oxide and magnesium oxide. There are other phenomena as well behind the swelling, but these are the main items. And assessing the steel slag's free calcium oxide and free magnesium oxide is not always easy. There are many physiochemical methods and techniques, but they are not always reliable because this material also interacts with the environment and so on. And plus, we still, even if we can predict, we can estimate the free calcium oxide, free magnesium oxide, it's difficult to estimate the predicted basically swelling in the long term. These are the issues with this material. So there are many different tests in the literature, what we use to predict the long-term tests we do, CBR tests, to predict swelling, but there are also other tests developed specifically for steel slag. These are accelerated swelling tests, either done at high temperature, high pressure environments so that we can find out what would be the maximum swelling. However, all of these tests have some drawbacks because each one is not, for example, European steam test was, now it's not used anymore, but it was used more for the asphalt applications. And we really have to use the correct test for different application. Each test method has its own characteristics. Today I'm going to focus on long-term CBR tests. I have done many different tests to see and to try to correlate them and use different mixtures, but basically today I'm going to focus on the long-term performance. So motivation is to reach the zero waste target, basically. And for high value recycling, we need to understand how these tests correlate, and we need to find some sustainable mixtures. Majority of the mixtures used in pavements either use lime or cement. However, if we can eliminate the use of lime or cement in these mixtures, we are reducing the carbon footprint and really producing new geomaterials that could be sustainable. So this was the goal. In this research, I have used many different products, but today I'm going to focus on glass powder replacement. Recycled glass is another material that has, actually it is 100% recyclable. However, very few countries have remelt facilities that can recycle the full glass, basically. And waste glass is milled down to fine particles, that's glass powder, and this is what I used in my research. And the previous research studies have used glass powder for partial replacement of cement in mortars and concrete, for partial and full replacement, as well as it is used as a cement, like in soil stabilization as well. So the idea here, the question was, glass powder can be a good source of reactive silica that may help to alleviate the swelling potential of steel slag. That was the idea. And so to generate cementitious reactions in the steel slag glass powder matrix. So these are the materials I used in the research. On the left, basically, you can see the basic oxygen furnace steel slag that I used. This was a granular material. On the right, you can see the glass powder. Both of them I supplied from Turkey. And what I did was I developed a experimental program with the steel slag, and I have also use 3 replacement ratios, 5% glass powder replacement, 10% and 20%, from chemical composition to gradation, compaction, hydraulic conductivity, and I ended with long-term and even accelerated swelling tests to see the results. I would like to start quickly with the chemical composition. For the basic oxygen furnace steel slag, I put some boxes to point out because I'm going to come back to this at the end of my presentation. This is like the highest range for a basic oxygen furnace steel slag. It had a very high calcium oxide content. As you can see, glass powder, as expected, it had very high silica content, but something to point out was the low alumina content, and I also had the sodium, high sodium. So this is the gradation curves for the materials used here. As you can see, it's a granular material for the steel slag on the left. And it can be a good sub-base material as it is if it did not have the swelling issue. So here you can have a quick look at the particle morphology. We can see sub-rounded to angular shapes, very strong material, medium to high sphericity, and this was the surface texture of BOFS. This is, by the way, SEM, EDS-supported SEM. And this is the particle morphology for the glass powder that I used. We could see the visible angular edges here, and then I can show you on a closer look up here the edges and the surface texture of the particle. When I looked at the compaction behavior, what I have observed was glass powder was filling the voids in the matrix, an increase in dry unit weight, and there was a shift to the left, indicating there is a drop in the required optimum moisture content. And basically, when we looked at the hydraulic conductivity of these materials, the saturated hydraulic conductivity, what I observed was both BOFS and the mixtures have lower hydraulic conductivity than when I compare those with the materials that have the same D50, same gradation, that indicates some interparticle cementation. And I did some long-term swelling response tests. I monitored them almost close to 2 years. Here you can see my samples. The blue ones are showing the steel slag samples, BOFS samples, and the green one, the pink one, and the dark red one are showing the mixtures, basically. So almost no improvement was observed, actually, with glass powder replacement. So I was interested to see also the average strain rates person per day with time. And as you can see, from 6 months to 18 months monitoring period, I saw the mixtures exhibited higher swelling rates than the original BOFS sample. So this is a discussion of what doesn't work, actually. So when we look at the mechanism, I did also took out the samples from the swelling test and looked them under scanning electron microscopy, EDS-supported microscopy, BOF samples. I could see the Portlandite crystal over there, hexagonal crystal. And then when I looked into BOFS, basically GP mixtures, for example, in this one, we are looking at 20% replacement sample after the swelling test. What I observed was like ettringite-like formations, but they weren't ettringite. Actually, they were when we looked at it, these looked in the closer view, these have low calcium to silica ratio. Material, these are precipitates and gel formations that have lower basically calcium to silica ratio than the gels. So what was my expectation? My expectation was to see CaSH gel or CSH gel. That's what we see in cement, basically hydration, but this wasn't the case. And then I looked into the literature, what could be happening that I see these aggravated swelling rates with GP replacement. What I'm thinking happened is that because this material had lower alumina but high sodium, there are some studies in the literature basically explaining that NaSH gel may cause this aggravated swelling rates. That's what I am suspecting. Their CBR response were excellent, by the way. I will not get into that. And this is what I was expecting. This was the CSHLs that I see in fly ash replacement, but this wasn't the case for me. So basically, just to summarize, 5%, 10%, and 20% glass powder replacement doesn't seem to be alleviating the swelling of steel slag, basically. And more research is required, but this was mainly attributed to the creation of unstable precipitates and gels that have much higher silica to calcium ratio than what we see in CSH and CSAH and CSH gels. And more details of this research can be found in the bold, basically, reference that I have. And I would like to thank TÜBİTAK, BİDEP 2232. This was a project given to me, and this was a comeback project. And I also would like to thank Boğaziçi University for supporting me to be here in this conference. But last but not least, well, I did not have students. Mr. İsmail Cantekin and Demet Mansuroğlu helped me with the experimental research. And if you have any questions, please email me at these emails addresses, please. And thank you very much.
Thank you very much. Maybe we will leave the questions for the last part of the session because we have here discussion also. So now it's time for Jovan Papik. And the presentation is entitled Conducting Complex Oedometer Tests on Municipal Solid Waste and Implementing the Findings in Numerical Modeling of Vertical Expansion of Landfill.
Thank you. So the title is a little bit longer, probably will not fit the recommendations given by Springer earlier today. So, in fact, these are extracts from the research conducted by Angela Temelkovska as a part of her master thesis. Recently, she shifted in a role of a mother, but she is actively following the activities and events in Europe. As employed in the State Environmental Inspectorate, she is in charge for the landfills in Republic of North Macedonia. According to the special plan, there are about 7 regional landfills that are supposed to be designed and built. Unfortunately, the situation is not developing according to the plans. So alternatives are looked for, and an example is taken from the northwestern part of North Macedonia. It is a mountainous part, forest area, seismic prone zone, many springs, Among them, there is a part of where from Skopje as a capital is getting water from. Of course, the syndrome not in my backyard is always present. So one of the alternatives is to look for the existing landfills and to extend their life. There is one it cannot be classified as fully sanitary landfill, is the Rusino so-called landfill. Despite that there is clay subsoil, unfortunately other elements are not fitting the criteria for sanitary landfill, but we don't have others. So it was opinion to look after its vertical expansion. Of course, there are a couple of challenges that are arising with this. There was some German companies, Switzerland companies dealing with, but so we look forward to its realization. As a part of recent investigation works, a couple of some quantity of material from the landfill surface has been taken on its perimeter, and they were embedded in edometer tests with in edometer cells with 10 centimeters diameter, 3.2 centimeters height. This is a so-called middle size of cells, and the samples were embedded with different saturation degrees. So a couple of them were with so-called 0 saturation degree, so let's say with natural degree of moisture content, and there was no further water placed in the cell. A couple of samples were installed with 50% of saturation degree, and only the bottom porous stone has been filled with water. And finally, a couple of samples were embedded with 100% of saturation degree, so it was a standard, let's say, edometer test. Larger range of loads has been applied from 25 to 200 kilopascals, simulating other events that are going to happen, so either placing the liner, passing of machinery, and the forthcoming layers of landfill, of the new landfill that would be expanded. And each load was led to act from 7 to 10 days, so 25 kilopascals, 7 or 10 days, and so on. So it took a couple of months to process all the samples. Findings will be presented in the following two slides. Here is comparison of compressibility coefficient for 0 saturation degree, 50% and 100%. So what we can see is that either we look for 0% or for 50% or for 100%, that there is a good agreement between the results from the same saturation degree. Also, the coefficient of compressibility for 0 and 50% is up to 0.25 or 0.3, while the highest compressibility would be was registered with 100% of saturation up to 0.35. Some other elements that could be noticed is that either here for 0 or 50%, generally there is finding close results. So similar can be mentioned also for the edometer modulus of compressibility. So the values are given here. Of course, with the lowest saturation degree, we obtained the highest parameters, so up to 2.5 megapascals, and as we increase the saturation degree, it has been fallen below 2 megapascals. While with the lowest load, it's about 500 kilopascals the modulus. In diagram point of view, in the diagram view, it can be seen at this slide. So these parameters, accompanied with others that have been a part of her research, have been implemented in two softwares based on finite element methods. One is FEM module from the Geo5, and the other one is Settle3 from the Rock Science software. Just to mention that generally the profile tested was that there is 20 meters clay subsoil with given parameters above. There is existing waste from 2 to 8 meters depth, so general average was taken as 6 meters, and two new waste layers of each of them with 3 meters. And so generally the procedure has been conducted both in Geo5 and in Settle is the same. So in the first phase we analyze the actual situation with the existing waste. We are adding the modulus of compressibility that we have obtained with 50% of saturation as an average, let's say, value. And in that case, so we took about the load that has been applied according to the self weight. As we add the next layer and the next layer for the existing waste, we are increasing the modulus. And in the last phase, let's say, for the existing layer of waste, we will take the largest, let's say, value for 100 kilopascals modulus obtained. For the first new layer, we will obtain with modulus obtained for 100 kilopascal, and for the last new layer it will be for 50% and for 50 kilopascals self weight, and the machinery as well. So with Geo5 we obtained about 80 centimeters 90 centimeters settlement. With Settle 3 it was about 80 centimeters settlements, which reasonably close results. So what has been concluded, what has been found, that waste compressibility varies with saturation levels. Since we have been testing a couple of samples for a long time, we have cross-checked the values and increased the reliability of the design and the modeling, and so it can contribute in further in the landfill upgrade, at least for that location. These parameters would be useful for countries where a lack of data is obvious, for example, and of course when we are facing landfill siting and design limitations. And this is just a contribution, just to have this comic stays. This planned to be a comic, not to become a real one. Okay, thank you.
Thank you very much for your presentation. Now we can move to the last presentation of this session. The paper that is going to be presented is titled Engineering Behavior Assessment of Weak Soil Stabilized Using Amalgamated Geopolymer with Industrial Waste, an experimental study. The speaker is Arvindan Sivasuriga. So the floor is yours.
Hello. I hope you all good. Good morning, everyone. And my topic travels engineering behavior assessment of weak soil stabilized using amalgamated geopolymer with industrial waste, an experimental study. And first of all, I should let you know, everyone, that this project was done by my professor in India, Mr. Dr. D.S. Vijayan, and his scholar, Mr. D. Parthiban. Due to some personal issues, they couldn't able to come. On behalf of them, I'm explaining this. And my area is structure, and I hope I will do the best for this presentation. Yeah, in construction industry, nowadays we are experimenting with a lot of new techniques. I feel geopolymer is one among that. Since 2008, there have been a lot of research has been done in geopolymer. Before 2008, it was very plenty of research has been done. But now the geopolymer technique has been widely used. After 2008, in the last 16 years, the geopolymer technique will adopted throughout the globe by applying a lot of research from the top level institutions to low level institution. According to their capacity, they are doing the research. This experimental study focus on waste material conducted in it's an industrial waste. In India, there is a place called Pandruti from down south. There are a lot of waste has been generated by industry, which is one among that is cashew nut shell ash, which has been done. The waste has been tons in a every day. So this project is about how we are applying that waste to stabilize the soil as much as we could. Problem with traditional methods of stabilization. Clay soils, we all know that clay soil have a high plasticity and causing damage settlement in structures like pavement and runways. And due to low permeability, the water will settle the clay soil. Because of that, many of the issues like the soil is just unsuitable for high-rise building and heavy load structures. And a lot of problems has been faced, which includes sulfate reaction in cement and lime stabilized soil can lead to heavy heaving and pavement failure due to the muddy surface of the soil. Cement and lime stabilization have significant environmental impacts due to CO2 emissions and resource depletion. Traditional stabilizers are ineffective for soils due to high organic content and sulfate. Alternative materials such as eco-friendly material, waste materials, or geopolymer with industrial-based admixtures are needed to enhance the environmental sustainability and performance. The study's objective is to improve its application of geopolymer with various proportion to predict the optimal proportions, which one is performing to the best. So the study compares the performance of stabilized clay soil using cashew nut shell ash, which has been CNCA based geopolymer with lime treated soil. The study identified problematic soil with a high plasticity and determined the composition of CNCA geopolymer matrix and optimum percentage of lime required for stabilization. The study assessed engineering behavior, strength, durability parameters. Materials. Initially, the FITR analysis was conducted to get to know the properties of cashew nut shell ash, and the silica and alumina was around 38% and 26%. And the soil for the study was taken from Sirdhavur Lake in Chengalpattu district in Tamil Nadu, India, that focusing the pre and post stabilization process. The soil was sieved around 425 microns, and the CNCA was burning at the shell, was kept at laboratory temperature 750 degrees Celsius. It contains high levels of silica and minerals, which helps in improving the compression strength and durability. FITR was used to characterize the constituent of CNCA. As per the result, the cashew nut shell ash lacks the hydroxyl groups but contains aliphatic hydrocarbons and carbonyl groups and proteins. The geopolymer synthesization, as we all know, this alkaline activator is required for geopolymer. So this is sodium-based geopolymer technique. So sodium silicate plus sodium hydroxide has been used and mix it together for 24 hours to produce alkaline alkylator. And so that the final proportions will be the geopolymer synthesization has been carried out. Method of stabilization. The UCC samples were prepared with clay soil and wet with geopolymer and lime stabilizer. Quality checks were done to ensure absence of foreign substance in the soil before casting the sample. Cylindrical specimens has been made, proportions of lime and CNCA with the constant water percentage. Soil samples were cast using the hydraulic jack compressor and cured for 7, 14 and 28 days in airtight covers. Specimens are also prepared with the CNCA geopolymer using different molarity levels, and curing methods include ambient temperature and temperature curing in laboratory oven. Result and discussion. According to our study, there has been with plain sample with 0%, 2%, 4% and 6% was conducted. Then for this curing period was a strength of lime stabilized soil with CNCA. We have seen that increasing for adding 2% lime improves the soil's initial strength slightly, while increasing to 4% significantly increases the strength, reaching maximum to up to 1378 MPa after 28 days. Increasing lime content without CNCA caused soil to gradually lose strength. Equal proportions of lime and CNCA with the 6% significantly contribute to the study. Strength assessment of stabilized soil using CNCA GP based on molarity. Different molarity percentage has been used. In that, 9 molar plus 2% CNCA was considered to be superior when compared to other percentage in the study. However, 9 molar with 4% also provide somewhat similar result. Then both can be adopted in a future study. We can be work on more percentage. It's a strength assessment of lime versus CNCA GB. The study evaluated the stability performance, and the sample has been cured for 28 days. The UCC strength of stabilized specimen with the CNCA GP shows better improvement in soil strength compared to lime. The addition of lime with the CNCA did not affect the strength enhancement of the soil. Treating the soil with only CNCA and geopolymer resulted in better improvement due to formation of durable and dense aluminosilicate matrix. Stress strain behavior was conducted, and everything was the total geopolymer content was not so brittle, and it was significantly contribute to our result due to stress and strain. You can see in the stress and strain graph. Durability assessment. The soil stabilized with lime and combination of CNCA exhibited more weight and reduced strength due to hydration formation of cement compounds. Equal proportions of lime and CNCA mixtures shows better resistance to moisture related issues. CNCA GP stabilized soil displayed lower weight gain and superior resistance to water ingress due to the development of dense geopolymer matrix. And over Atterberg limit, the things which contribute to overall the CNCA GP shows a superior result in all the primary study we have seen. In microstructure analysis also, the study shows that the voids are filled and cohesive. It shows strong bonding between the soil particles. In conclusion, it has been concluded that addition of 4% lime improved the strength of stabilized soil. 9 geopolymer to 9 molarity enhance the reactivity, and the study use of CNCA GP instead of lime in soil stabilization yields optimum results, and offers potential sustainable engineering geotechnical practice. Thank you.
Thank you very much for your presentation. So now we should move to the discussion. However, we do not have a lot of time, so maybe 1 or 2 questions maximum. So are there any questions to our presenters? So maybe if not, then we can go to eat lunch. Yeah. Yeah. During the lunch we have the poster session, so we also invite you to go there and just look at the posters. Thank you very much.
Welcome everyone after delicious lunch. I have the pleasure for leading this last but not least session with Irem Zeynep Yildirim from the Bogazici Institute from Turkey. My name is Tomasz Godlewski. I represent Building Research Institute from Warsaw, and our session called Environmental Geotechnics for Climate Change. I have one proposition, because we have not a lot of time, that we will listen all presentation, and after that if you will have some time for discussion, I hope we do it. Okay. So the first speaker, I would like to invite Tugba Eskisar. Yes. Okay. And present us a brief look at the perlite geopolymer soils. Please, the floor is yours, and remember, you have 10 minutes.
Thank you for the nice introduction, Thomas. Okay. Is it okay now? Okay. Okay, I will keep it so close. Thank you for the nice introduction. Today I'll be reporting the master's thesis of my student, the very beginning of her thesis, Miss Esma Rahat's thesis. I work as an associate professor in Ege University, Izmir, and the title is A Brief Look at Perlite Geopolymer Soils. I have been a fan of this conference series. As you can see, it all started with Professor Reddy in 2019. Then it's followed by the conference that was held in our country in 2022. And last year, we were in India. All of them were beautiful conferences, and the one in Poland is also very beautiful. I thank to all the people who made it happen. So, we know that easy way of stabilization is, or the traditional way is just using cement or lime for improving shallow soil layers. But when we check how much cement was produced in Turkey, we can see that 85 million metric tons were produced in 2022, and a part of this production was consumed in soil stabilization works. So we know that large amounts of carbon dioxide emissions occur due to the consumption of cement. So it represents a hazard to the environment. Some other alternatives are necessary. Geopolymers could be used as an alternative, as they are modern and eco-friendly alternative. And they are also used in various geotechnical applications. They provide technical, environmental, and economic benefits. For the people who are new to the geopolymerization, I can tell that it's a quick chemical process that includes 4 stages: dissolution of silica and alumina and ions, ion diffusion, and gel formation by polycondensation of the alumina and silica complexes with an alkaline activator. You definitely need an alkaline activator. And the last phase is gel hardening. In this study, we used kaolinite clay. When we classified the clay, it was a low plasticity one with a specific gravity of 2.55. Raw perlite was also used in this study, and it was obtained from a mineral deposit already available in Izmir, Turkey, and the major compounds were silica dioxide and alumina oxide, and the specific gravity was 2.24. Why we used perlite? Because we have so many. As you can see, Turkey has 74% of the world's possible perlite reserves. Of course, they are used in many other industries, but we have to find new ways to consume it. Perlite is formed by the cooling of lava from the acid phase of magma, And it's a type of volcanic glass that contains water droplets due to water absorption through capillary cracks. As a liquid activator, we use sodium hydroxide solution, of course, in solution form. The sodium hydroxide was in bead form, it was white colored, it was very easily soluble in water, and it was high in purity. The preparation stages of perlite geopolymer soils, first step was the dry mixing of kaolinite clay and perlite. Of course, we had to sieve it in order to integrate it with the clay soil. And then sodium hydroxide solution. Some samples contained 2 molars, some samples contained 4 molar concentrations of sodium hydroxide. In the end, you can see that we had a mixture of perlite geopolymer soil specimens. The experimental program consisted of compaction and unconfined compressive strength tests. The major variables were perlite content, sodium hydroxide, solution molarity, curing time, curing temperature. And first I will present clay perlite mixed soils which were prepared with water in the first phase. Then we proceeded with the solution. Here you can see the liquid limit of the specimens decreased with the addition of perlite content. Plastic limit did not markedly change after 20% of perlite content. Therefore, the major factor that is changing the plasticity index was the liquid limit of the specimens. Here you can see the compaction curves, and the navy colored one belongs to the kaolinite soil itself. The brown one contains 10% of perlite, and the red one contains 50% of perlite. So with the addition of perlite to the specimens, optimum dry unit weight and maximum dry density decreased. From now on, I'll be reporting perlite geopolymer soils which were prepared with sodium hydroxide solution. But I have to emphasize that, of course, we had to do the compaction process very quickly to get these data. So the reactions hasn't started yet while we are doing this compaction. So these are the results. I can tell you, I will not show you because we don't have time, but optimum water contents were almost the same with the ones that were prepared with water. Here you can see the dark brown soil that contained 30% perlite had the highest dry unit weight. It was apparent both in 2 molar and 4 molar solutions. Here you can see the unconfined compressive strengths of the specimens. You can see molarity has an effect, curing time has an effect, and the temperature has an effect to change the strength of the specimens. 4 molar specimens had higher strength, as well as 40 degrees Celsius temperature cured specimens also had higher strength. Of course, the curing time, the specimens with 90 days had the highest strength. In this graph, you can see that the specimens with 40% perlite, with 4 molars of sodium hydroxide solution that were cured for 90 days, had the highest strength. It was around 6,000 kilopascals. So briefly, to sum up, in this study, we focused on the Atterberg limits, compaction properties, and unconfined compressive strengths of perlite geopolymer soils. The liquid limit and the plastic limit, the plasticity index of the specimens decreased with the addition of perlite. In clay perlite mixtures, the maximum dry unit weight and optimum water content decreased as the perlite content is increased. And the highest strength of perlite geopolymer soils was obtained with the samples that contained 40% perlite, 4 molars of sodium hydroxide that were cured for 90 days under 40 degrees Celsius. Yeah, I think that's all. Thank you so much.
We thank you very much, Professor Tuğba Eskişar, for the nice presentation and using the time very wisely. The next presenter I would like to invite is Lucas Wojcinski, presenting new approach for estimation of ground freezing using probabilistic analysis.
Thank you very much for a nice introduction. I represent Warsaw University of Life Sciences, and today, in cooperation with Professor Tomasz Godlewski from the Building Research Institute, I will present our probabilistic analysis on soil freezing depth and its significance for environmental geotechnics and construction design. Due to the possibility of heaving when designing foundations, it is required to choose a safe foundation level that is below the designated frost depth in a given location. This mainly applies to objects erected shallowly, without a basement, directly, and also utility connections, sewage, industrial installations, water supply, roads, parking lots, and railways. Freezing issues may affect those elements, so it is important to correctly determine the extent of ground freezing and to maintain a minimum foundation depth on underlying soils. Freezing the ground is a complex random process in which many factors affect the final results. Low air temperature is the basic initiating factor here, especially the duration of negative air temperature. Other factors are the amount of precipitation, snowfall forming the snow cover, wind speed, which affects the shape of snow cover and its thermal conductivity, vegetation coverage, and soil type, its consistency, chemical composition, water and air content, porosity, arrangement of layers, and degree of preconsolidation. It should be emphasized that a lack of snow in low temperature conditions can significantly increase the range of freezing, and that dry soil tends to freeze deeper compared to wet soil. The maps of ground freezing have been given in Polish standards since 1950s. The freezing depths were calculated calculated in centimeters using formula given in Soviet recommendations, and this approach was based solely on air temperature measurements. Today, ground freezing depth is determined by direct measurements using thermometers installed in the ground. In Poland, ground temperature is measured every day at meteorological stations of the Institute of Meteorology and Water Management, State Research Institute, and the measurements are made at the testing sites, which at the measuring plots, such measuring plot is a part of a ground with an area of 2 by 4 meters. Free of the grass, and the measurements are made at depths of 5, 10, 20, 50 and 100 centimeters, and the position of the 0 centigrade temperature is determined by interpolation. Data from 45 meteorological stations covering over 40 years of observations were collected and used as input data. In the analysis, we use annual winter maxima of soil freezing depth, and the aim of the analysis was to find such values of the freezing depth that would be exceeded with accepted probability in appropriate reference period. Nowadays, the commonly accepted annual probability of exceedance for climate actions is 0.02, which corresponds to a 50-year return period. The predicted values are calculated after approximating the
empirical distribution of the annual winter maxima of soil freezing depth with a certain probability distribution. So the aim of the study was to fit a theoretical extreme value distribution to a given set of winter maxima of soil freezing depth. As in case of other climatic interactions, the Gumbel probability distribution is appropriate for forecasting the position of the zero isotherm in the ground. This distribution has two key parameters, the location parameter U and scale parameter alpha. And these parameters were estimated in our study using so-called blue estimators. These estimators are recommended in the European standards for climate actions, and this method was introduced in 1974 by Julius Lieblein in his work Efficient Methods of Extreme Value Methodology. Numerical results include estimated Gumbel distribution parameters and predicted ground freezing depths for selected return periods. And those predicted ground freezing depths were first calculated according to the Gumbel distribution and next scaled using appropriate correction coefficients to take into account the type of the substrate. In the framework of this study, various kinds of plots have been developed for individual stations, presenting predicted values compared to the empirical values. And we can see that in case of most stations, we can see the progressive climate change. We can see that the green-colored lines at dots referring to the latest data, the last decade, are located lower, which indicates downward trend in freezing depth. These plots illustrate predicted and empirical measurement values over time. The horizontal axis is the time axis, and the predicted values are calculated by horizontal lines. And it can be seen that the value predicted according to the old approach given in the Polish standard is exceeded, or in other cases unnecessarily too high, in relation to empirical values. And the new approach, the new approach is safe and at the same time closer to empirical results. And also, as a result of the study, a new map of ground freezing has been proposed. The map was generated based on estimation from data covering years 1980 to 2022. The isolines were drawn using the Kriging method. Correction for subsoil condition was applied. The zonal values were assumed as averages from stations classified to a given zone. It's worth noting here that the zone of deepest frost shown on the map coincides to a large extent with the area of the lowest average thickness of snow cover and the least rainfall in the warm season, that is the lowest soil moisture in the last 10 years, according to the data from the Institute of Meteorology and Water Management. The smallest precipitation amounts are visible in the expanding area from Mazovia to Wielkopolska and the western border of Poland. Recent observations and reports from the Wielkopolska region suggest instances where the newly constructed road sections are being damaged by frost heave despite their proper design. Let's come to the conclusions. The obtained results point to the need to narrow the forecast period due to the pace of climate change. The predicted values for the 50-year return period should be updated every 10 years. The results obtained for most stations indicate a decreasing trend in freezing depth. This can be explained by the fact that nowadays we are experiencing almost no long-term frosts during winters. In places where the visible trend is ambiguous or the opposite, like Wielkopolska or or Mazovia region, it may be due to the fact that in recent years we observed almost snowless winters with low precipitation, leading to hydrological drought, which, along with low air temperature, may result in increased ground freezing. The new approach for estimating ground freezing depth, the probabilistic approach, is more accurate and which takes into account air temperature, snow cover, and ground conditions, is more accurate than the old approach based solely on air temperature measurements. And the proposed new ground freezing map based on direct measurements and current observations, including type of subsoil, is necessary for correct assessment of environmental impacts during results from climate change. Presented probabilistic approach for ground freezing phenomenon estimation should be implemented in the national annex to the next generation of Eurocode. For the details, I would like to invite you to see our articles on the subjects and or contact us by email. Thank you very much for attending our presentation.
Thank you, Dr. Wodzyński, for the perfect timekeeping. And now the next presentation, it will be spatial variability of methane oxidation in landfill soil cover, large-scale tank experiment. Authors Guram Verma, Yoti Cherry, and Krishna Reddy, but I see that this presentation will be presented by Jagadish Kumar Yanga. Please, the floor is yours.
It's on. Good afternoon, everyone. My name is Jagdish. I am a PhD student at UIC, but this work is of my colleagues and I am presenting on their behalf. So the presentation is about spatial variability of methane oxidation in landfill soil cover, which was a... Okay, so this is the presentation outline. Basic presentation outline starts with an introduction, and then research objective, research methodology, results and discussion, followed by conclusions. So starting with the introduction, as we all know, landfills, the main gases emitting out of landfills are methane and carbon dioxide, and these are greenhouse gas emissions causing climate change. So in order to control these emissions, the main approach that is taken is the use of gas extraction wells, but these gas extraction wells have their own limitations in terms of radius of influence, as you can see here. So the unextracted gases, they accumulate at the top and then they slowly diffuse out into the atmosphere. These are called as fugitive emissions. In order to control the fugitive emissions, landfill covers are used. So these landfill covers, usually the methanogens present in there will oxidize the methane that is getting emitted. The problem here is this methane oxidation varies spatially, and we wanted to see how much the variations will be. So that's why we performed this large-scale tank experiment by simulating this cover in the laboratory. So as I mentioned before, the research objective is to investigate the methane oxidation potential of landfill soil cover and assess its spatial variation. The tasks are basically to simulate the cover system using a large-scale test setup and then analyze the spatial variation of physicochemical characters of the soil cover after the experiment is done, and then examine the spatial variation of methane oxidation potential after the experiment is done. So the methodology here is, this is the large-scale field tank experiment that we have in our lab. So the three layers that we have put in this tank are basically the cover soil that we have got it from Zion landfill in Illinois. And then on top of the cover soil, as a drainage layer, we have used silicate sand. And then on top of it, again, we have put the topsoil. This is a basic required landfill cover system. So the sand is basically silica sand acquired from US Silica. Geotextiles that we have used to separate the layers was obtained from the liner company. And geocomposite that was placed at the bottom to uniformly distribute the gases that we inject was obtained from Scabs Industries. These are all the material characteristics we have characterized. And then the testing program basically included a 304 days period of testing. So the first phase is basically pre-incubation phase, where
a small concentration of methane and mostly nitrogen was injected in order to acclimate the landfill cover soil and make the methanogens active. The second phase is moderate flux, where we injected 24.9 grams methane per meter square per day. The inlet gas concentrations are basically 50% methane and 50% carbon dioxide. This phase ran for 113 days. And then in the third phase, we introduced a small amount of hydrogen sulfide in order to check its effect on the methane oxidation using similar flux rate. This phase ran for about 74 days. In the fourth phase, we wanted to see what happens if we increase the flux and then we double the inlet flux. This phase ran for about 39 days, and in the fifth phase we brought the flux back to what it was in second phase in order to see the effect of inlet loading on the removal efficiencies. This one lasted for 43 days. After this 304 days of experiment, we have systematically extracted the samples from different layers and then performed basic material characterization, and then also performed some batch experiments to see the methane oxidation potential of the soil. So these are the locations where the samples were collected. So the batch tests that we have used to measure the methane oxidation potential after the experiment are here. So we used a small 50 ml container. We put 1 gram of soil in there, 1 or 2 grams, and then 20 ml of free air, normal air is extracted out of that container, and landfill gas containing 50% methane and 50% carbon dioxide is then injected into that container, and then the changes in gas concentration profiles will be monitored over time. So that is a batch experiment. So the results are here. So as I mentioned, 5 phases of testing. As you can see here, in the second phase, where we used moderate methane flux, maximum removal efficiency was seen, about 99.78%. And then when we have introduced hydrogen sulfide, the efficiency has fallen down. As you can see, 97.49. And in the fourth phase, when hydrogen sulfide was in the fourth phase when the flux was too high, the lowest efficiency was observed. And because the methane is getting converted into carbon dioxide, the negative removal efficiency in carbon dioxide can be seen here. So same thing is mentioned here. And then after the experiment is done, we did some basic characterization. As you can see here, there are slight changes in moisture content. In the top layers, the moisture content has decreased because the water has seeped down to the bottom of the cover. And then very minimal changes were observed in the organic content, and the pH at 30 centimeter layer has reduced significantly. This may be because of reaction between carbon dioxide and water, and no substantial changes were observed in electrical conductivity after the experiment. And then spatial variation of moisture content, as I mentioned before, the locations of where the samples were collected were across the cross section. So in order to see the spatial variation, we measured all those things. So the moisture content spatial variation is presented here. As you can see, there are spatial variations. There can be many reasons for these spatial variations, including the amount of oxygen available and the amount of water available and the amount of methane that is going through that location. So all these different reasons led to these spatial variations. And then the pH was almost same in most of the layers except one of the layer where it reduced drastically. So the spatial variations were also not much except at this layer. Again, the reasons are all same because of varying methane and oxygen availability and water availability. These are the variations in methane oxidation potential after the testing is done. The methane oxidation potentials of the soil at 70 centimeter layer, which is at the center of our biocover, soil layer, was the highest, and the spatial variations were also significant, as you can see here. And at 50 centimeters and 85 centimeters, the methane oxidation potentials are very less compared to 70 centimeters. This is because the methane was more active in oxidizing the methanogens were more active in oxidizing the methane at the center. So the soil there was having high methane oxidation potential. So to conclude the study, I aimed at examining the spatial variations in physicochemical properties and methane oxidation potential in a landfill soil cover system. So we used that near field scales setup that I've shown, and then different phases of testing was performed, and I've explained all those all those variations in methane oxidation because of different fluxes and because of introduction of hydrogen sulfide. And no significant change in physicochemical properties of the soil cover was observed, except at one depth. And no spatial variation trends were also not very significant, but the spatial variations are there, showing that in a landfill, you cannot assume that the methane oxidation is constant throughout across the landfill. So that's about it. Thank you. If you need any further information, you can visit our website. We acknowledge the funding of National Science Foundation for this project.
Okay, thank you very much for the great presentation. The next presentation is the predictive modeling of flexural strength of concrete manufactured with recycled aggregates, a comparative analysis by Rajwinder Singh, and Mahesh Patel will be, I think, presenting.
Thank you so much, and very good afternoon to all. And this is Dr. Mahesh Patel. I am an assistant professor in Department of Civil Engineering and IT Jalandhar. So today I would like to take you on a different ideas to learn how we generally do the experiments and how we go for some advanced technologies to understand or predict the flexural strength of the concrete using machine learning and AI. So there I am going to show you a few methods how we can carry out that work and how we can predict it. So first of all, before going ahead, I would like to introduce what are the actually construction and their utilization wastes are now being available in around the world. And we can see that due to the rapid growth in urbanization, industrialization, that has actually become a boost nowadays to do the development. There are a lot of developing countries like India, they require a lot of construction activities that is actually can be identified and can see in the current scenario. So due to this demand, obviously there will be a problem of sustainable material and how these practices would be sustainable, because it requires a lot of natural materials like sand, gravel, and obviously we have to produce the cement. So the problem is that how we can provide the alternatives to these all the requirements. So as we can see, there is due to the modernization, what we are doing is to demolishing the older buildings and constructing new buildings, new roads and everything. So that's actually causing a lot of development of, or you can say production of demolition debris. So if we will be able to recycle that particular material like coarse or fine aggregate that we are getting from the waste, so that will be obviously a crucial point, or you can say crucial process to make it sustainable. So here we can see there are uses of these significant improvement of material if we will able to utilize in the existing material, or like we can replace the natural material by this recycled material. So that obviously will help us in different ways. So in this regard, I have just would like to tell you that there are a lot of studies has been carried out in past at least last 2 decades, and people have worked to suggest a lot of proportions then how we can utilize this recycled waste material in the development of concrete. So here our idea is to if we are able to bring the technology in particular methods, then how we can make these sustainable tools like framework, so that we can utilize those
models to predict whatever the strength of those concrete. So here our idea is to how we can predict the flexure strength using machine learning AI, because this is nowadays a beginning. Everyone may be thinking like how we generally use these machine learning tools so that we can predict, because these tools actually work like just like a human brain. So we can say that the recent research has utilized range of machine learning models. We can see there are a lot of models were used in the past, like linear regression, decision tree, random forest, artificial neural network, gradient boost, and others. So these are all models actually based on how would like to predict whether we will. If I will tell you in short, there are two types of model. If we have to predict something, or we have to classify something, so that depends on what is our purpose to use these methods. So there could be two types of learning, like supervised learning or unsupervised learning. So just like our human brain, if we are telling our brain that if we have to do the 1 + 1 = 2, then it will be automatically calculated and it will be programmed. But if we will be telling that there are two apples, then you have to recognize whether they are apple or not. So obviously this is a supervised learning. So, so in this particular study, I have used two types of models: adapted boost regression model, that is AdaBoost, and there is extreme gradient boosting regression, that is XGB. They are actually the regression model. They work on to learn how the data actually behaving. So according to that, they provide how we can get the results. So in this particular methods, we generally divide the data that was available around 302 data points, and that can be divided into 80 by 20. So, so here we have included 9 input parameters as compared to the previous studies. They have used only 4 or 5 input parameters. Here we used 9 input parameters. That will actually enhance our understanding for predicting the flexural strength. So obviously assessment, we will go for the statistical assessment of these models. So like errors and other matrices, we will be also going for the Taylor and diagrams that will also will help you to understand the standard deviation. So these are our input parameters, and these are the basic details like cements and natural fine aggregate, recycle fine aggregate, natural coarse aggregate, and all these abbreviations would be utilized. So there we can see this is the input data properties that was available for different compared with the flexural strength. So these are the histograms. And if I would show you the results, then once we have utilized these methods, because we have used only two methods, there are several methods, but these methods actually are based on how we can get these results adequately. So that's why after comparing 4, 5, or 10 models, we have shortlisted only 2 models. Those were actually providing the better input and output values. So after 80% of the training, we have worked to understand this performance, and we have observed that the XGB model was performing better, was giving the value of R square was around 8.3. And if you will see the Taylor's diagram, that is also suggesting the deviation from this particular model. We can say the standard deviation was very less as compared to the AdaBoost model. So here we can see, so there was around falling here. So that is suggesting this is performing working better than as compared to the other models. So lastly, I would like to conclude that. So this was only used 2 types of regression models actually we have used, that is also called supervised learning. And if we are going unsupervised, then we'll have to go for the deep learning. So here we have concluded, I would like to conclude that after using these models, we have observed that XGB performed better, and it shows the value of R square was around 0.83. That is obviously can be modified in future, because whatever the data we were having, that data actually modify the performance of the model. So we will increase the number of inputs, then obviously our results could be refined in future. And there is also possibility to go for vice versa. Suppose we have to calculate this much of strength, then how we can get the input values, then what would be the percentage of all the cement, sand, fine aggregate, coarse aggregates. That can also be done in future. So that's it from my side. Thank you. If you have any question, please ask.
Thank you very much for a nice presentation and time discipline. And the next topic in the next presentation, it will be the climate change impacts and vulnerability assessment of the coastal environment in terms of particle size and their distribution. And this will be presented by Arivazhangan Rengasamy. Do we have this speaker on the stage? No? There is no second name. Rengasamy.
The fifth presentation.
The fifth presentation. There is any person for this presentation? No? So we skip that, yes?
Okay, so we would like to invite next paper, pore fluid effect on the suction behavior of sand kaolin and sand bentonite mixtures by Feyza Toygar and Yeliz Yükselen Aksoy. I think Feyza will be presenting. Yep.
Thank you. Can I use it? Okay. Thank you, chairs. I am Feyza Toygar. I'm PhD candidate from the Kuzeyli University, Turkey. I'm talking about pore fluid effect on the suction behavior of sand kaolin and sand bentonite mixture. In the world, when the population increase, we need energy and generally, fossil fuels are commonly used, but depletion of fossil fuels and fossil fuels cause environmental pollution problems. So we need environmental and sustainable energy and energy structure for this environmental and sustainable energy. Bentonite was often used as a buffer material, especially in nuclear waste repositories and solid waste landfills. Bentonite is preferred due to its low permeability and high absorption capacity. The degree of saturation of bentonite used as buffer material is important considering the change in water level over the years. And suction depends on water content, bentonite content, and time of hydration. Total suction, sum of the metric suction and osmotic suction. We measure the metric suction, and metric suction depends on relative humidity due to the difference in air and water pressure on the water surface. We investigated suction of compacted sand bentonite and sand kaolin mixtures. We can see the ratio of the sand bentonite and sand kaolin. As pore fluid, we used tape water, sodium chloride, and calcium chloride solution. These both of the solution we use 0.5 molality and suction measurement by the non-contact filter paper method. This filter paper method cheaper and practical, so why we use it. The physicochemical properties of materials were measured at laboratory for bentonite, kaolin, and sand. Also, the chemical properties of tape water were measured at laboratory. You can see in the table.
When we look the phase of experiments and preparing after the sample, sand kaoline and sand bentonite mixtures prepared according standard Proctor compaction curve. Target dry density 16 kilonewton per meter cube. Three filter paper sandwiched between the two compacted sample. After this, we sample placement into the glass jar. This glass jar little 130 millimeter volume size, and then this all of the glass jar placement into the desiccator, and this gas desiccator we place into the spatial chamber. The smaller filter paper sandwiched between two large size protective filter was taken with the tweezers and measured on a persistence scales. Measurements were usually taken every 3 to 5 days. The process was repeated until equilibrium is reached. Metric suction measurements were made using the non-contact filter paper method. Metric suction was calculated using below formula, wetting suction curve. According to sand kaoline mixture, the highest suction value belongs to 40% kaoline with 60% sand, sample with calcium chloride solution, and the lowest value belongs to 75 kaoline with 25 sand, sample with the tape water. In the presence of calcium chloride solution, the highest value belongs to 40 kaoline with 60 sand sample. The lowest value belongs to 75 kaoline with sand with 25 sand sample. When all compacted sand kaoline mixture were compacted, when kaoline content increases, suction value decreases. The salt solution increases the suction values the most. The effect of calcium chloride is more prominent. And when we look at the sand bentonite mixture, the highest value belongs to bentonite and the lowest value belongs to 75% bentonite with 25% sand sample with calcium chloride solution also. The sodium chloride and calcium chloride solution decreases the suction values of bentonite sand mixture. The salt solution decreases the suction value the most, while tape water increases the suction values after the 50% bentonite with 50% sand sample. In the present study, the highest suction value was found in bentonite, pure bentonite, but the suction values of sand bentonite mixture varied after change the pore fluid. In conclusion, as kaoline content increases, the suction value decreases. The salt solution increases the suction values of the kaoline and sand kaoline mixture the most. The effect of calcium chloride is more significant. The effect of salt solution is different for sand bentonite mixture than sand kaoline mixtures. The sodium chloride and calcium chloride solution decrease the suction values of sand bentonite mixture. Especially suction values of sand bentonite mixture were low in the presence of calcium chloride salt solution because of the divalent calcium cations. The result shows the importance of the pore fluid chemistry and mineralogy. And my references. Thank you.
Thank you very much. And now we have another small modification in our session. Right now, the two last presentation, it will be online presentation. So I would like to ask to play this presentation.
A very warm good afternoon to everyone who is present here.
I'm Nikhila. I'm a master's student from the Indian Institute of Technology, Kanpur, India. Firstly, I'd like to thank EGRWSC for presenting me with this opportunity to present my work online as I could not get my visa on time. So let me share my PPT. So our topic is the utilization of two industrial waste streams as potential replacement of natural sand for constructional purposes. I co-authored this paper with my colleagues Ankit Mishra, Yatharth Mittal, and under the supervision of my guide, Dr. Parthanarayan Mishra. So this is the table of contents. We'll start off with an introduction and then proceed to materials and methodology, and then follow that up with results and discussion. And then finally, we'll jump to summary and conclusions. Uh, Introducing the topic, literature states that above 50 billion tons of materials are mined out every year, out of which 60 to 80% of them are coarse aggregates. It is expected that there will be a 45% increase of sand consumption from 2020 to 2060. So, extensive sand mining in rivers poses problems like river erosion, intensive floods, habitat loss, and water pollution, etc. Therefore, it is important for us to search for an alternative for sand that can either completely or partially replace it. Um, there is the transition towards the renewable energy sources such as wind and solar and nuclear energy is being advocated, but there is still heavy reliance on non-renewable energy sources such as the thermal plant, etc. For instance, the coal thermal power plant in India generates about 75% of the electricity. There are two types of waste materials that is obtained from the coal industry, namely fly ash and bottom ash. Fly ash is the precipitate that is obtained from the electrostatic precipitator of the furnace, and the bottom ash is the unburnt part of the coal that can be obtained from the bottom of the furnace. Another waste stream that from the coal industry is the coal mine overburden. This is basically the soil extracted from mining during mining. Studies show that these waste materials obtained from the coal industry match sands in terms of certain geotechnical characteristics or properties. With this in view, the potential of bottom ash and coal mine overburden as a substitute for sand is studied in this paper. Uh, so coming to the materials, these are the geomaterials of interest in this paper. Uh, so the first one is the Ganga sand. Ganga sand is obtained from the riverbank of Ganga in Kanpur, Uttar Pradesh, India. Yamuna sand is sourced from Ken River, which is a tributary of Yamuna River, again in India. Um, Next is a bottom ash. Bottom ash, this is obtained from a coal thermal power plant in India. Next is the coal mine overburden. This is sourced from northern coal fields, Singrauli, India. These are the Indian standard codes that are followed for conducting these experiments. The first one, coming to the results part, the first one will be the grain size distribution. Here we can observe that the bottom ash covers a wide range in fine grained domain and sand domain. There is a higher fines content in bottom ash. Ganga sand covers a wide range of area in the coarse grain domain. It can also be seen that Yamuna sand and coal mine of overburden follow a similar trend within the sand domain. The coefficient of uniformity and coefficient of curvature showed that none of the selected geomaterials are well graded. Um, Next up, we conducted a specific gravity test on all the geomaterials. We can see that Ganga sand, Yamuna sand, and coal mine overburden have very closer values of specific gravity, whereas bottom ash has a specific gravity of 1.97, which is the least of all geomaterials. Uh, we can comment that there might be a presence of organic content in bottom ash. Next up, we performed a liquid limit test. Although it is unnecessary to perform a liquid limit test on sands, because we found out some finer content in bottom ash and coal mine overburden, we conducted a Falcon method or cone penetrometer method. to find out the liquid limits of these geomaterials. We can see that the bottom ash has a liquid limit of 24.75% and coal mine overburden has a slightly lesser liquid limit. This can be the higher liquid limit of bottom ash can be attributed to its higher fines content. This signifies its higher plasticity and higher compressibility. Next, we conducted a standard compaction test to study the compaction characteristics of all the geomaterials. We can see that the bottom ash showed a very flat compaction curve in comparison with the other geomaterials. It achieved a maximum dry density of 14.71 kilonewton per meter cube, whereas the coal mine overburden achieved the highest maximum dry unit weight of all the geomaterials, which is 19.62 kilonewton per meter cube. The sands, although they achieved a slightly lesser maximum dry unit weight than coal mine overburden. The flatter compaction curve of bottom ash obviously shows that it is less sensitive to moisture content variation. We also conducted a relative density test because the degree of denseness of sands can be better assessed through vibration compaction rather than standard compaction, and these are the results that we obtained. We also correlated the maximum dry unit weight obtained from standard compaction test and maximum dry unit weight obtained from vibration compaction test. We can observe that there is a good statistical correlation between these two parameters. The higher maximum dry unit weight in standard compaction test is due to the higher compaction energy compared to vibration compaction. It can also be said that the good lubrication properties in standard compaction test in presence of water than in dry state, allowing the particles to move easily. Next up, to assess the shear strength characteristics of the geomaterials, we performed direct shear test at 25% relative density. All these tests were carried out under dry conditions. That is, no water is added while testing. At an applied normal stress of 210.9 kPa, coal mine overburden achieved a peak shear stress of 150.1 kPa, exceeding Ganga sand and bottom ash. You can also see that Yamuna sand achieved the least maximum shear stress. Next, we plotted between normal stress and shear stress to find out the angle of internal friction and cohesion. Bottom ash showed a cohesion value of 4.2 kPa, whereas the other geomaterials had no significant value of cohesion. The coal mine overburden showed a higher value of angle of internal friction, which represents its mechanical resistance and stability. It can also be used in embankment fills and slopes, unlike lightweight clinker, which requires additional support. So due to the finer fraction in bottom ash, it can be partially replaced in a well-graded engineered construction material. So coming to the conclusions of the study, we can see that the grain size distribution results show that the coal mine overburden consisted of sand particles more than the fines content, whereas the bottom ash showed dominance of finer fractions. Consequently, the permeability of a coal mine overburden is expected to be higher than that of the bottom ash. Also, a higher liquid limit value was observed for bottom ash compared to that of coal mine overburden, again attributed to its higher fines content. During standard compaction, coal mine overburden yielded highest maximum dry unit weight compared to other geomaterials. The direct shear results demonstrate that the coal mine overburden sample resulted in the highest angle of internal friction amongst all the samples tested. So we can say that coal mine overburden can be used as a potential substitute for Ganga and Yamuna sands, partially or completely in terms of its mechanical properties. However, since the coal mine overburden or the bottom ash both are mine waste or industrial waste, it is necessary for us to conduct geochemical testing to assess any leaching which can be adverse to the environment. So that can be the future scope of this study. So this is my team. We are Physio Lab. I take this opportunity to thank my juniors, Smith and Radhika, for helping us. Mr. Harshal Verma for his support and guidance. And also, I'd like to thank my colleagues, Mr. Ankit Mishra and Yatharth Mittal for their unwavering support. I'd also like to thank my supervisor for his guidance throughout this study. Thank you so much.
Okay. Thank you very much for this online presentation. Before moving to the next one, if there's any questions, because this was an online presentation, we would like to take the questions now. Are there any questions for the presenter? Okay, are there any questions from the audience? I guess not. Okay, thank you very much. Now we are moving on to the last presentation of this session. It is optimization of medium for S. Bacterium and performance comparison with free ureas by Dhanesri Suresh. It will be again online.
Good morning, everyone. Today, I'm here to present on the topic optimization of medium for S. bacterium and performance comparison with plant ureas for geotechnical applications. Content: Introduction, bacterial culturing, experiments conducted, results, discussions, conclusions. Introduction: Biomineralization in soil is a natural microbial activity. Precipitation of more than 60 different biological minerals occur in soil, which includes carbonates, phosphates, sulfides, and silicates. Calcium carbonate precipitation in soil can be achieved through 4 pathways: urea hydrolysis or ureolysis, denitrification, sulfate reduction, and iron reduction. Among these, urea hydrolysis or ureolysis is the most utilized one due to faster rate of calcium carbonate precipitation. Urea hydrolysis or ureolysis can be achieved through MICP and EICP processes. Microbial-induced calcite precipitation process or MICP process can be initiated in soil by either bio-augmentation or biostimulation methods. The negatively charged bacteria attach to the soil particles or occupy the pore trough in MICP process. Following the addition, growth, and metabolic activity of the bacteria, there is urea hydrolysis mediated by the urease enzyme secreted by the bacteria. Calcium carbonate precipitates. Purified or crude urease enzyme extracted from plant, bacterial and bacterial and fungal sources mediate the ureolysis reaction known as enzyme-induced calcite precipitation. That is, in MICP process, a urease positive bacteria act as a nucleation site, whereas a nucleation site and urease source, whereas in EICP process, the free urease enzyme act as the nucleation site as well as the urease source. Purified urease enzyme is expensive and accounts almost 70 to 80% of total cost of process. So, when adopting MICP and EICP process as a ground improvement technique and looking forward to the field implementation to make the process economical and sustainable, optimization of this process is needed. As the urease enzyme is very expensive and the bacterial growth as well as the culturing process requires facilities like bioreactors and optimal temperature conditions. So optimization of this process is very much needed for taking these processes to the field level. Now, this diagram shows the MICP and EICP process. In MICP process, bacterial cells act as the nucleation site, whereas in EICP process, urease enzyme act as a nucleation site. And in presence of urease the substrate urea breaks down to ammonia and carbon dioxide, which then gets converted to ammonium ions, OH minus ion, and carbon dioxide. And in presence of a calcium source, that is calcium chloride, calcium carbonate gets precipitated. Now, the bacterial culturing in MICP process includes usually the strain is preserved at minus 80 degrees Celsius, and the strain mostly adopted is especially due to high urease activity of this particular bacteria. The bacteria is streaked on the agar plate, then gram-positive bacteria can be viewed also under the optical microscope. Autoclaved media is used for the growth of the bacteria. Inoculation is done inside the laminar hood, and bacterial solution can be prepared by inoculating the autoclaved media with colonies, fresh colonies from the agar plate. This shows the microscopic as well as SEM images of S. pasteuri. Experiments conducted here include media optimization for bacterial growth, growth curve and urease activity, pH versus time variation in MICP and DICP process, precipitation efficiency in test tubes, and SEM analysis. Media optimization for growth of estuary. So estuary has, in previous studies, estuary has been grown in different media. From them, we have adopted four different medias. So medium one is yeast powder and ammonium sulfate. Medium 2 contains peptone, yeast extract, NaCl, urea and ammonium chloride and nickel chloride. Medium 3 contains yeast extract and sodium chloride. Medium 4 contains yeast extract, tryptone and NaCl, which is known as the LB media or Luria bertani, the universal media. The bacteria was grown in all the four media and the growth curve was studied. It was seen that in all the four media there was an initial lag phase during which the bacterial growth was very slow. After that there was a log phase and then a stationary phase and then a decay phase. So, according to literature, mostly the optical density above 1 is adopted for MICP process. So the bacterial growth in M4 and M3 were above 1, optical density value of 1. The urease activity of the bacteria in these two media were observed and was seen that in medium 4, the urease activity was 5 Ku per liter. Thus, Luria bertani was confirmed as an appropriate medium for bacterial growth. Now, the optical density versus time relationship of Aspergillosis bacteria in Luria bertani media is shown. At the lag phase, the bacterial growth was very slow and the lag phase extended up to initial 6 hours. In the log phase, the bacterial growth was very high and it was between 6 to 18 hours, and in stationary phase the bacterial growth was almost steady or constant, and this was between 18 to 30 hours, during which the bacteria can be used for applications, for cementing applications in soil, and death phase is after 30 hours. These experiments were performed at temperature condition of 30 degrees Celsius, 200 rpm, and the pH of media was 7.5. Now, the mass of bacterial pellet in versus optical density relationship was obtained and was seen that in an OD of 1.2, the mass of bacterial pellet was about 0.446 milligram per ml. The variation of pH with time in MICP solution. MICP solution is a mixture of cementing solution which contains urea and calcium chloride as well as the bacterial solution. It was seen that the pH initially increases due to the urea hydrolysis and release of OH minus ions. Later, it starts to decrease. Similarly, in the EICP process, the increase was also spontaneous as well as the decrease was also very fast. It can be seen that the initially the pH increased and then later on the pH decreases due to the calcium carbonate precipitation reaction. The increase in pH is due to release of OH minus ions from urea hydrolysis, and the decrease is due to the precipitation of calcium carbonate. Test tube experiments in MICP were also conducted, in which 10 ml of bacterial solution was mixed with 10 ml of cementing solution, and precipitation efficiency was measured at different time intervals, including 3, 7, and 40, as well as 28 days. It was seen that in MICP process, the precipitation efficiency was low at initial days, which was confirmed with the variation of pH with time. Earlier. So it can be seen that almost less than 30% precipitation was observed at 3 days, and in 28 days the precipitation efficiency was up to 100%. The SEM images shows calcium carbonate precipitation, and using ADS it was confirmed as calcium carbonate. Test tube experiment in EICP process was also conducted. 10 ml of enzyme solution with an activity 5 Ku per liter, which is similar to that of the bacteria, was mixed with 10 ml of cementing solution, that is of concentration 0.75 molar. Incubation was at 30 degrees Celsius, 200 rpm, and SEM images were collected at different time intervals, and the precipitation efficiency was also measured at different time intervals. It was seen that in the initial 3 days itself, the precipitation efficiency was up to 50%, and in 28 days it was up to 90%. Discussions. It was observed that urea bertani was an appropriate medium for growth of Aspergillosis with a urease activity of 5 Ku per liter. In MICP solution, the pH increased from 7.5 to 8.8 and dropped gradually. The rapid increase in pH can be attributed to the release of OH minus ions following the urea hydrolysis. The decrease in pH can be attributed to calcium carbonate precipitation. The pH of EICP solution peaked to 8 in initial 6 to 12 hours, which later dropped, and indirectly representing the urea hydrolysis and initiation of calcium carbonate precipitation. The variation in pH with time indicates faster rate of calcium carbonate precipitation via EICP compared to MICP, which is further confirmed from the precipitation values obtained. Conclusions. It was observed that Luria botany was an appropriate medium for growth of S. pasteuri with urease activity of 5 Ku per liter. SEM images show calcium carbonate precipitates were formed through both MICP and AICP process. In precipitate from EICP process, vaterite to calcite transformation was observed in 70s. For field applications with time as a constraining factor, EICP can be more preferred compared to MICP process due to high precipitation efficiency in 3 days or in 7 days. References. Thank you.
Thank you very much. It was last presentation. Right now we have some time for little discussion because of this unexpected modification. And also it is the last call for any other presentation, last minute presentation, if someone wants to present something. Okay, maybe some questions to the to our speakers to this all presentation. Yes, please.
Thank you. I have a question for Professor Tugba Eski, sir. Here I am. So I found your presentation very clear and interesting. And I understand that you mix the components in a dry state.
Yes, that's correct.
In order to carry out laboratory activities.
Yeah, in order to provide homogeneity, first of all.
Yes, so my question is, when you imagine an upscale of your procedure, for example, in a large-scale construction works, you have probably a soil that is wet.
Yeah.
And you have to add the component and have a less controlled mix.
Yes, that's correct.
And you imagine this would be a problem, or if you think you can overcome it?
Yeah, we are looking for a way to do it because it's a further step in our research. Right now we are trying to define how the soil will behave because there is not much literature that is focused on how the perlite will behave inside the soil. We basically know that it's rich in sodium, potassium, and silica and alumina hydrates. So we are hoping that it will create a mechanism with the addition of sodium hydroxide. The alumina and silica will be able to dissolve easily from the inside the medium. Of course, this is just a preliminary study right now, but I'm sure in future we will find a way to answer your question properly.
Okay, thank you.
Thank you.
Thank you. Any other comments or questions?
I may have a question. I have a question for the second presentation about the ground freezing, the frost depth. I just wanted to check what would be the design implication of your findings. How would that affect the design of foundations, right? Because this research has something to do eventually with the design and embedment depth of footings. That's what I'm guessing.
Well, I think that concerns the level, the foundation level, right? So we have to choose correct foundation level, minimum foundation level on the underlying soils, and well, in terms of design, right? That's what you mean?
Yes.
And well, also another protective measures are used in the form of appropriate built-in frost protective layers. So there's also a solution, right? Appropriate solution. Well, no, well, definitely the awareness of the of the impact of ground freezing and the factors that that have influence of the death of ground freezing. I think that there have to be consulted when designing foundations and facilities somehow combined with buildings erected shallowly.
Thank you.
I would like add to this questions some comments. Of course, it's not problem typical for the buildings, but especially from the when you have the deep foundation level, it's no problem, and the building is hitting. So yes, but some kind of light buildings, shallow garage, yes, it could be problem, and also as Dr. Wodzinski say that the problem how take into account when you calculate the layer of the load layer construction, yes, and also the large diameter installation, right, for water and gas. So we must take into account this level of ground freezing. Okay. Any other questions, please? If not, I would like thank you all, especially the speakers and my co-chairman. Thank you very much, and I close this session. Thank you. Stuff, yeah.
Design would be conservative in your codes. Yes. That's what the rule is showing. So you will have
old map from the 50 years. So
yes, so that's what I was meaning.
Yeah.
The results show like you could do more economical design.
it not will be problem that the last 10 years. The snow cover.
Specialization, innovation, and
I'm so bad at speeches. Oh. Okay, ladies and gentlemen, actually 2 days ago we were just starting with our ceremony. Yesterday I was saying welcome to Warsaw, and it's time to say thank you and goodbye. These pictures, you know, it's not working. Okay, thank you. So actually it looks like we are closing the 5th International Conference of Environmental Geotechnology, Recycled Materials and Sustainable Engineering, but just only the official part. These pictures, you know, this was the first one, the second one, a third, fourth, and the 5th one. So actually, our 5th conference is in the books. I have another picture. Yeah, this is us. And I would like to thank very much the organizing committee, Professor Koda. It was a huge job. Thank you. Alexandra, she was not sleeping for 2 months, not eating. Anna, I cannot see Anna, but she's always hiding. You never see her, but she's always with us. And of course, me, you can see me all the time. Once again, I would like to thank our collaborating institution and partners, of course, sponsors for their support. Thank you very much. And our team, thank you very, very much. You know, most of the people you haven't seen, but they were doing a great job. All the PhD students, all the students, all the employees, you did a great job. Thank you very much. We were in crisis many times, so you couldn't see it. So thank you very much once again to all of you. Of course, I would like to thank our special guest, which means Dr. Ballows. Thank you very much. Professor Krishna Reddy, you are a star. You know, you made it happen. I mean, you helped all the time, and also we couldn't see you. Thank you very much. Professor Kamesela, you have a huge job in front of you.
I will be there.
Thank you, and we will keep our fingers crossed. Professor Denes, you are always with us. Thank you very much. And once again, to all our participants and our guests, we are really very happy that you made it, you did it. It was also difficult with all the visa, all the documents, I know. So I'm very glad you are here, and I think we will meet very soon again. And I have an introduction, because this is your part. There are only 2 slides, but of course. So once again, thank you. Oh, I did it.
After dancing.
Dancing was.
Okay, thank you very much. As I assume that you already know that I'm the organizer of the new conference. I really appreciate the invitation to do it from Professor Reddy and the rest of the people responsible for this conference. It's a tough work because the level is very, very high. I don't know if I can get such a level, but we are going to try to do it our best. Well, the next conference is going to be held in 1 year, in June. You see the dates there. Vigo is not a very famous city. Okay, everybody knows Spain, everybody knows Madrid and Barcelona and other cities, but probably many people do not know Vigo. Vigo is right in the north of Spain, in the Atlantic coast, very close to the frontier of Portugal. Okay, so and this is not my presentation. Okay. Okay. And Okay. So I would like to introduce my university. The university is a relatively new university, although some buildings, some schools are much older than the university itself. It's got 3 campuses in 3 different cities in the same region, and Vigo is the main campus where the university is. So I have a small video so we can see it.
Specialization, innovation, and internationalization. Committed to creating solutions for the society it serves, the University of Vigo has established 3 areas of specialization, which run parallel to the capabilities of each one of its campuses. Vigo Tecnologico, a vital talent center for innovation in strategic sectors. The Campus de Auga in Orense, with its capacity for outreach and creating economic and social value with water as the focus. And Campus Crea in Pontevedra, which unites and connects art, sports, health, society, and communication. With almost 100 registered patents in the last 5 years and thousands of agreements with businesses and institutions, the University of Vigo reaffirms its commitment to the strategic grouping of research groups, as well as its role as principal investigator on large projects. After several years of financial stability, we have become the only academic institution of the Galician university system with a surplus. We have gone from being a plan to being a future reality. We are the University of Vigo. Your university.
Okay, as you can see, we are in the main campus is the technological campus, and in the technological campus we are in the School of Industrial Engineering with 2 buildings. One building is the oldest building of the university, is in the city, and the other is in the campus just 10 kilometers far from the city, not very far. Well, we are going to go into the conference. The idea is to keep the philosophy and the main ideas of this conference. We are going to keep the main topics for the conference about solid waste, sustainable geoinfrastructure, environmental geotechnics, and sustainability, the same topics. And the idea is try to combine the connection, the collaboration, and grow in the scientific and also in the professional and personal aspects among all the participants in the conference. Well, the idea is to expand the conference as much as possible. Here we have some countries that probably are going to participate because people from these countries made part of the scientific committee, and the idea is to expand with other countries all around the world. Well, for the conference, we are going to publish as soon as possible the call of abstracts. The idea is to register online, to submit the abstracts. Before the conference, you're supposed to plan your trip and book your accommodation. We are going to provide some hotels with a special fare rate for the conference. And finally, plan your trip. Vigo is a vibrant city, it's a coastal city by the ocean, and the city grows mainly due to the port activity and the industrial activity, and there is an interesting combination of industry, commercial, administration, and the university that makes a vibrant city. That is the collaborative spirit that we want for the next conference. And this is where we are. We think that this is a convenient access for all the possible participants. We are not in any main airport in the country. Vigo has an airport with some international connections, but probably for most of the participants, the best option is to fly to Madrid and then connect with another flight direct to Vigo or with the fast train. Alternative airports could be Barcelona or also Porto in the north of Portugal, because there is an easy connection between the airport of Porto by bus directly to Vigo. It's just 1 hour and a half. And there is Porto is a well-connected airport with especially European destinations. So probably you can find a direct flight to Porto. Well, we think that Vigo is a perfect location. It's a city that spreads along the bay, and you can see a combination of industrial areas, the city. The university is not very far from the city center. Originally, Vigo was a village of fishermen, but due to the commercial activity in the port, the fishing and other industry, it grows very, very fast in the 20th century, and now is the most populated city in the region. Well, if you visit the city, you can go for the old town, the narrow streets, old churches, or perhaps you can go to the modern part of the city with modernist building and new infrastructure. Or perhaps you go around into the islands and the parks that surrounds the city if you like nature and open spaces. There is a vibrant nightlife that you can enjoy after the conference. And if you prefer the cultural part, there is a set of interesting places you can visit in the prehistory, Roman remains, churches from 800 years ago, the castle, modernist buildings in the city center, and the modern infrastructure. So I contacted the city, and they gave me this promotional video, so you can have an idea.
Emerging from the water upwards, rising towards the hills. Sea, sand, stone, forests that lean over and look out to the sea. Follow the footprints of sailors from times before, others who arrived like me. Julius Verne, Francis Drake. I imagine the privateers' anchors, their ships anchored at the bay, sheltered from the winds beyond the Diaz Islands. And I think this port is still the ideal place to rest after any battle. I roam through shipyards, loading docks, ships, fish markets. It is the sea that feeds, that moves, transports, creates and offers, and it never stops. Sailors and mermaids, fishermen, swimmers, explorers, men of the sea, merchants. Every symbol, a clue that will always lead you back to the sea. Past and present live together hand in hand, and only a few yards in, I walk over the steps of those first men from Vigo. It's like traveling back and forth in time. I'm discovering the secrets of this land. Life is celebrated around a table, 3 times a day ritual. An authentic buffet of flavors, colors, scents, and sounds. La fiesta, it is not something that happens in a precise time or space. It is the Latin way to live day to day. Music lovers, the people and encounters, every opportunity is good to get together. Listen, laugh, and toast. Time stops when it gets dark, and you understand truly why the night is longer and brighter. If you want, it'll never end. Una noche de Vigo, it is not easy to forget. Iberic culture and Celtic character. Latin roots, Atlantic blood, a land of legends and realities, traditional and cosmopolitan, industrial and rural, 1,000 Vigos in Vigo. A city that cannot be conquered, where you are the only one that could be conquered.
So now?
Yeah, I was wondering.
And that's all.
Maybe we should take swim dress, you know?
Sorry?
Where is this request?
Where?
Where is this announcement?
Yeah, well, all the information for the conference is in the webpage. Well, the idea is to send all the information by email to all the attendees of this conference. And I also give some brochure. Yeah, and the webpage is also in the brochure, and the email, that one is in the email. Okay?
Thank you very much. Thank you. We are out of schedule because the bus is waiting, but still, I think Dr. Valos said that you were...
Can you hear me? Yes?
Yes.
Well, I'm going to be very, very quick. So now, if they ask me what is a successful conference, you made it easy for me. It was really successful. Really. It's about perfection, everything on time. It's about the ambiance, the technical keynote lectures. I didn't attend all of them, but they were very good. The speakers, everything was perfect. I want to congratulate you and the team. Even you, Piotr, where's Jacob, the driver, was very fast. I loved his driving. Where are you? Here you are in the back. He was fast. I loved his driving. And you people at the reception, the young, they were all fantastic. Thank you so much, Professor, and all the teams, the founder. And thank you for having me. I felt at home. Thank you so much.
Yeah, I know. I don't want to take too much time. As I said, like bus is waiting, so we want to continue to have fun. So yeah, I echo what Mark said. You know, it's a fantastic conference, and Professor Koda, you know, I have known him for many years, so he took on the challenge, and the team, right? So did a great job, and the most successful part of this conference is DNS attending the conference. I don't.
Thank you.
So, yeah, because he doesn't attend the conferences overseas, doesn't attend the conferences in India. He able to attend this conference means it's very, very special. So I think, you know, I want to thank organizers for a fantastic job, as Mark said, but also I want to thank all the attendees, you know, presenters, you know, excellent job overall. So I don't have anything negative to say. It's you know, as Claudio said, you know, he has a really, like, he was feeling bad about, like, how could he meet the standards, high bar these people have set up. But overall, you know, it's a very good. Thank you so much. Yeah.
One more thing. I discovered that I am not the only good geotechnical dancer. You are all super good. Thank you.
Last year we go especially to Bombay to invite personality. Professor Anant here.
And it worked.
And Piotr give some short information about this evening.
Yeah, that's right. So the plan for now is to take a couch. So the couch it's already waiting. It's gonna take you to the hotel. People from ECAR dormitory, please take a walk. And then you're gonna have like 45 minutes like 30 minutes, let's say, just to refresh yourself. Please make sure that you wear comfortable shoes, and it's gonna be like a casual dinner. But we're gonna be walking around the old town with the tour guide, so make sure that you feel comfortable in your outfit. That's quite important to notice. And yeah.
Shorts are okay?
Absolutely fine. It's gonna be a barbecue party at the boat, so really, just flip-flops would do the job too. In the evening, it could get cooler a little bit, but not lower than 25, 23 degrees. Yeah. During the night, well, depends. If you, there's gonna be like, there is, yes, please take something warm. If you, yeah.
Because we will be on the boat.
Yeah. I came.
And then we will go swimming, so you can take.
Yeah. Okay. So for the trip from the boat, there's going to be like there is a schedule for 2 buses. The first one is going to pick you up at 1:45 midnight, and the other one will be 1:45 a.m. as far as I remember. No, 12:15. No. We will send you an information. all I will take care.
He wants to party more.
Yeah, that's the arrival time. The arrival time. Okay, but all right. Please.
We will send the information. So.
Yeah, on the group. Please make sure that you follow all the information on the WhatsApp group. Okay. Yeah.
Exactly as I said.
Thank you.
Thank you. One more. I'm sorry. I just wanted to say that today joined us my mentor, my Japanese Motainai, Professor Matsui Yasuhiro. We are so happy you were able to join us. Thank you very much. And one last word to Professor DNS, another mentor. You know, I have so many mentors.
I don't know what. Well, keep it up, and I think you should maintain Krishna's legacy. One word of suggestion or caution for you. I think this should be a 3-day conference, not 2 days, at least. Because by the time you start contacting people, discovering them, and the goodbye comes. So if you really want to do some good brainstorming and good science, I think you should give time to people, make it 3-day minimum or 3.5 day. Yeah. Okay. Unwanted suggestion.
So now, yes, please run. Catch your bus.
We just wanted to give you a little souvenir.